Well, I heard it
Anyone?
earlier. And this
He
is
said the Earth measures flat.
Yeah.
does the Earth measure horizontal?
Yes, he just now cited a survey manual.
Yeah. And
No,
not
it
only
says that
that,
what it actually said when you cited that manual is that the discrepancies from horizontal at short distances
so you
are
can treat them the
negligible.
same. Correct.
Right.
Right,
So
which
for
means you
all
measure
intents
it
and
flat.
purposes, you can treat them the same because it's so small. It doesn't
So you
mean
can treat the Earth as flat.
it doesn't say that there's zero deviation. It says that it's so small that it's negligible.
Yeah, but okay, now they use that same type of method, that plane survey, for up to 100 square miles. So after 10 miles in each direction, right, you go 10 miles at 66 feet, which means that the Earth will have dropped multiple feet below that horizontal. So they're not the same.
They do
Right.
up to 10 miles,
Yeah, 100 square miles.
100 square miles, and they don't factor in the curve correction.
Correct.
That's the usual for a datum. Yes.
That's false.
Well, I can quote literal civil engineering manuals that say that. So,
I'd like to see that.
okay.
If GPS is being used in a 1 acre survey, they're using curve.
See, that's what you do. See, that's what they always do. So the actual plane survey manuals say that, but they're saying, well, GPS is built on the spherical coordinate system, and we'll just use survey, so it accounts for it anyway. Trust me, bro. When it comes to actual physical measurements and how they're taught and how the survey is done, it's called plane survey, and they use plane survey in civil engineering up to 100 square miles. And we just covered that they consider the curvature negligible, which is why when you go talk to a plane surveyor and you tell them the actual rate of curvature after they've been surveying for years, they will actually think you're wrong. Like normally they think that that's way too much curvature, that can't be correct.
I mean,
So
we're in the spot where I have to say the condescending thing. Well, big if true. So I need you to show that to me, and then
okay.
I'll be with you on that. But who you're talking to, by the way, this is my buddy Phantom Thoughts. He just came in. This guy is a land surveyor, and he trains surveyors. He kind of like
Yeah,
knows
so
this stuff.
Yeah, the 100 square miles thing, that's just not that's not an accurate way to represent, flat or plane surveying methods versus geodetic surveying methods. It's just not. It's we use we use geodetic surveying methods for small scale project. Anything that requires geodetic coordinates like highway projects, uh, utility corridors, for example, their whole network is based on geodetic coordinates because they couldn't have a pretend flat plane. Their their design drawings, maps, etc. They wouldn't fit together throughout the whole network across an entire state. Obviously,
You're making our
So-
point even stronger.
the distances are different on a pretend flat plane than they are on the actual Earth's surface. So
That's what
Right.
we're saying. If your claim of the Earth's surface was true, they would be so different. You couldn't do what they actually do.
Like what?
And I've done for years before GPS was a thing. Okay, I'm gonna read this.
Can you post
Okay,
it so we
in
can read
civil
along?
engineering, a 100 square mile plane survey refers to a surveying project where the area being measured is considered as a flat plane, suitable for smaller areas like 100 square miles where the Earth's curvature is negligible, making calculations simpler and using standard surveying techniques like chains, tapes, and levels appropriate. Essentially, it's standard land survey that doesn't account for Earth's curvature due to the relatively small area being measured. By the way, there's like this is well known. There's a name for it. 100 square plane survey.
Can you
Plane
post-
surveying, not talking about
can you post that?
geodetic that you brought up, Phantom.
So the reason that they're saying that is because everything's measured in these shorter segments. So you're still measuring over the curve, but you're basically applying these short segments of measurements and survey setups that can be treated as individually flat.
Yeah,
And
horizontal line segments, right?
Yeah, but just minutes
But-
ago you told me that I don't use it for
flat-
100 square miles.
we don't, because here's why.
Okay.
If I pretend if I ignore the curve and take a measurement on a globe and then go a mile out, the distance along a curve is longer than the distance along a flat theoretical plane.
I know that's why we're making it as an
Not gonna
argument
work.
for flat Earth.
It's the
So
the difference in the distance is bigger than what you're saying.
Can I ask a question?
No, that's
So-
my point. We're saying it's bigger than they're acting like it is, and they're using the benefit that the Earth is actually flat to still be able to do it accurately, far beyond what you'd be
Bottom
able to
line-
do it accurately on if it was a globe, and they did this way before GPS even existed.
So bottom line, I know, but geodetic surveying, exactly. So the results that we get using geodetic survey methods, where we use a globe models and projections, those results, the measurement results we obtain from that would not be possible on a flat Earth. You
So
can't
you
apply
just completely
certain
deflected.
formulas and get the same results that we get on a flat Earth. We have the results that we get would only be possible if they were measuring on a globe. Period.
Yeah, my brother, we agree that there's a fundamental difference in the two. And so he went and read straight from a surveying manual that says you can just treat it like they're the same. And we're saying, no, you can't do that. Certainly not for the amount of distance that they actually
You
do
can't.
plane
You
survey
can't if
for.
you're doing
And then you deflected to geodetic surveying.
the
We're
book.
talking about,
Bingo.
first you said that they don't use it up to 100 square miles. They
It's
do.
overgeneralizing in that book. So, like what I'm
100
saying is,
square miles, bro? You said that wasn't true.
yeah, no,
100,
what
100
I'm
square
saying,
miles sounds like a lot. I mean, it's 10 miles in
Yeah.
either direction.
depending on the type of project
That's
they're
still a
using,
lot.
nobody is doing a plane survey that's 10 miles with conventional plane surveying methods anymore, anyways. But the
Yeah,
Oh,
because it's already been
anymore?
it's been reified. Yeah.
Yeah, they just put it into the GPS assuming the sphere now. That isn't the
It's
point.
not
The point
assuming
is
the
that you
sphere. I
can
just
do
told
that.
you.
That's what was done forever before GPS, where you just assumed
We don't
reified.
just put it into the GPS though. We have to reference the GPS to hard points on the ground that are on the globe.
Yes, and I'm
Geodetic
going to
Witsit, can
encourage
you
you not
post
to
that thing
take
that you
this
read,
leap.
please?
Just a second. I'm going to encourage you not to take this leap where you pretend like you have just treated like it's flat and saw the difference, because you haven't. And if you're actually a surveyor, I encourage you to go out and test it, because guess what? This is what makes flat
We
earthers
test
a
it
thing.
every day. We test it every day. If we don't apply, if we misapply the corrections that I'm talking about, if we don't use scale factors, etc., we get predictable errors no matter where you go.
You do
Predictable
not get,
errors in reference
dude,
to what?
yeah, you're going to try to
The
claim the
globe
curvature.
versus flat. Like
That's
No, no, no,
not
no,
true.
no, no. What are
if I
you
don't take
referencing? What are you referencing? WGS 84? What datum? What do you?
for us, it's GRS 80 in the States.
So
Okay, so
what are
you're
these big
saying
segments that you're measuring out where you're saying that if you don't account for the curvature, you're screwed? Give us an example.
So we set the control for these projects, and we can't have our control overlapping each other. Everything has to line up, and the further you go, it's basically a scale difference. So we have to apply a scale factor to our measurements to
you know,
convert globe measurements to flat plane measurements. If we don't do
You
that
didn't
correctly,
answer my question.
it's approximately 7 or 800, say an inch for every 1,000 feet. So if you go, or we can say a tenth for every 1,000 feet. So it's basically a half a foot in each mile, approximately.
Yeah, you're
So you'd have
connecting lots.
differences.
So,
You'd have an error distance every mile of a half a foot if you don't apply these corrections.
well, okay, that's what you're saying, but I know many plane surveyors that do it assuming that it's flat and it works. So you just saying that it doesn't work doesn't change
No,
it. I asked you for a
not,
specific. You're
they're
saying
assuming it's
no.
flat.
You're
You're mixing up the point that I'm trying to make. I'm saying if we're using geodetic surveying methods, geodetic models.
we're
okay.
talking about
Those are
plane
fundamentally
surveying, bro.
different. That
So
assumes spherical geometry. That assumes spherical geometry at the beginning. It begs the question. And actually, you have to make a lot of corrections because the Earth doesn't match those assumptions. And yeah, it's like on average,
you will not
15 to
get the
20,
you
on
will not
average,
get the
15
same
to
results
20%.
between two geodetic control points. You will not get the same results using plane
Geodetic
methods.
control points. Think about what you
Right.
just said.
So you're taking plane methods and you're just pretending it's a plane and traversing for 10 miles.
No, I asked you for a real life
If
example
if
because
you
you
did
made the.
actual geodetic measurements between the beginning and end of that 10-mile traverse, you would have an error. Period.
Yeah, because
Have
you're
a
using it way greater distances and then accounting
you
for
would see
all
it. You would
kinds of
see the error, and
errors.
you can see the distance in a mile. You can see the distance in 1,000 feet. It's just small. It grows. It's like a scale
But
factor.
That's
It
what
gets
you're
bigger
just
the
saying that
farther you
because you
go.
believe it. I asked
No,
you
it's
for a
not that
real life
I
example.
believe it because I use it every day, and if we
Okay,
don't make
give
these
me a
corrections,
real life example where if you assume the earth was flat, you're going to get a predictable, consistent, progressive error.
I just told you that the distances would not add up. So if I go
No,
far enough
what's an
along a
example
highway
of like what kind
corridor,
of project? Oh, like a
like a
highway.
highway corridor, I'm saying that 20 miles of highway corridor, I should have had X amount of I don't know, just name some type of quantity of material that's used in that. really it's more for control because everything is built and poured in these smaller segments. So you're only seeing it in the right of way mapping, and the base mapping. That's the background for all the design for these projects. So
Yeah, you're starting to red pill yourself right now because your
no, I'm
whole
not
argument
red
was that you are though, because I've had this conversation with surveyors multiple times. You just said that it's just based on small segments. You're like, yeah, but you're just doing that in small segment. And then the one
Right.
example that you
Try
gave
to
us, which
connect,
was like a
if we try to connect 20-mile segments of projects together, we're gonna have an error. We're gonna have overlaps in our
Hold on. You said connect
coordinates.
those segments, right? Connect those
Yes.
segments, and then what? In reference to what? Your geoid, the GRS.
Yeah, in reference to
Of course, it's
exactly
gonna be wrong, bro.
like this is the point we're making. When you
I mean,
made
of
that
course it's
highway,
gonna be wrong.
when you made that highway, you connected small
The
segments
geodetic
together.
measurements are true and correct because you can verify that, like I said, with hard monuments on the ground. We have hard monuments. You can go back and reverse engineer the whole system and take and make celestial observations, or take
Oh,
like the continental transcontinental traverse. You can make those measurements all from scratch, recalculate, basically rederive the whole system on these
have you done that?
coordinates if you want to. No, I'm not going to do that
Okay, because
because
because you're making the
all those
assumption that
all
you can
those
do that.
all those corrections have been applied into the system, and if we
Right.
don't apply them,
Yes,
we get
reifying.
the error that we get is predictable based on all those
No,
calculations,
it's not. It's not.
correlations.
You're
Yes,
no,
it
it's
is.
not. Those errors are considered individual to location, and they actually make
No,
a
it's not.
deflection. They make a Yes, it is. They make a deflection of the plumb line. So they use the celestial coordinate system, and they make a gravitational deflection of the plumb line, and they change it based on whatever the actual outcome is and how off it is. Because there are
Exactly.
gravitational
They
anomalies, bro.
correct it back to the
You're talking
geoid
about
that's in
geoid
reference.
models. That's for heights. I'm talking about horizontal distances. Heights, we treat horizontal measurements and heights as two different
You
things.
don't have
Two
horizontal
different
measurements.
what we refer to horizontal measurements are x along an x and y grid. Everything that
Yep.
we take everything from the globe and we project it and correct it into a flat model to be used on a map that you would lay on a table,
You take
or a
everything
flat
from the globe and
model.
then you correct it into a
Yes.
flat model. Yeah, that's
Yeah,
right. You have
we
to
make it flat,
correct
so
the assumption of a
it goes
globe.
on because all plans are designed. Everything is designed to simplify the calculations and drawings, and everything's done for engineering design. It's
Yeah, it's
simplified,
simplified to reify the geoid that you're trying to reference.
Well, no, he's
Exactly.
saying that they take the globe and then
for
they
the
correct it
purposes.
into a flat. Yeah, yeah, we know that's what you do because
I
reality
think
is
he's
flat.
mixing up his words there, but
No,
I
we
get where
take
you're
globe
coming from,
measurements and
Phantom.
we apply corrections to make a flat deliverable that the engineers can use and the mappers can use in the office and treat as a flat plane for
Oh,
this to simplify the
That's our
calculation.
point, and this is the bigger question here: is when you take the small segments, you make the
If there was
highway.
no curve, we would never have to apply corrections to make it flat in the first place.
If there was no curve, we would never have to apply corrections,
Yeah, he's
dude.
saying they take the measurements on the curve and then they flatten it out for usage like on the draft.
No,
They
they don't.
times it by
What?
Yes, we
What
do.
no?
Yes,
0.99997.
we
what?
do. AutoCAD,
No,
everything's done in AutoCAD with X, Y, and Z. So you're looking at a
that's right.
flat
You keep on
computer
talking
screen,
about them. If a dude, you keep talking about a
drafting
model that
everything,
assumes the Earth's a
plan view looking
sphere.
directly down X and Y coordinates,
You
Cartesian.
keep, brother, you keep
That's how
talking about a
everything
model
is
that
done.
assumes the Earth's a
Everything is
sphere.
done.
In factual reality, we make adjustments for topography. If you want to make a horizontal stretch of a highway,
Topography is
you're
measured along the Z-axis. It's separate from the X and Y
That's
axis.
what he's
you're
saying.
just making
What's
my
happening right now at Witsit is you're mixing up the measurements. You don't understand the concept of how even
just
the X,
made
Y.
my point.
No, I didn't make your point.
You
You're
did, dude. So let me finish the one
conflating
point here.
vertical measurements and horizontal measurements, two different things.
Look, you
No,
seem
he,
cool and all, bro, but can I finish my point, please? So if you make the highway, you just said, and we all know that you connect small horizontal line segments. You then claimed and you neglect curvature altogether. Now you're claiming that, oh, we know that by the end of say that 10-mile segment, we know how much it's gonna be off. Yeah, we do too, 66 feet.
You can
But
measure it. You
in
can measure it
reality,
though. If
you're
you
not
don't apply
actually
a
off that
scale,
66 feet.
if you
I
don't
know many
apply that
people. I know
scale,
people that own entire companies that build runway or highways that are flat earthers that have been doing this for 20 years. So
they're
this
not
like
licensed surveyors. All they do is go out and
they literally
they're not,
own a
unless
company
they're
in
using
They own
Michigan
a
that
company,
get
dude.
government grants.
yeah, nonsense. They if
Oh,
they're
so you think I
using
just
if they're
lied about
building
that?
highway projects, they're using they're using geodetic coordinates.
Geodetic again. You're going back to.
It's like, yeah, because he can understand the difference in like a model that presupposes a sphere and then how you just basically trash that for real life when you're going to go build it. And you said that if you build two 10-mile segments, I have a simple question. We're going to correct, because this is your model actually claimed that if you do it in small enough segments, gravity's accounting for it without you even noticing it.
No, I'm saying in small enough segments, you don't see the difference. Like if you're pouring concrete for a segment of highway and it's 100-foot pour, 200-foot pour, 500-foot pour, the difference in the distance along the curve versus the distance along the theoretical flat plane is so small that it doesn't need to be factored in. It doesn't make
That's my point.
quantity of concrete that you're going to use. It's
yes, because your model claims if you do small enough segments that whatever's on the ground itself is automatically accounting for the curvature because of gravity. So, but this is the point though. If I connect 10 miles of horizontal line segments, and then I go do that again, you made a claim that you wouldn't be able to connect them; they would be off.
Yeah, if you try to drop a 10-mile segment in between two other 10-mile segments without correcting the for curvature, they would overlap each other. So if you did a pretend flat plane survey across these two 10-mile segments that were say 30 miles apart, and then dropped another 10-mile segment between the points where those surveys, those traverses, what we call it,
they would have error, right?
They would have overlap.
Yeah, if the globe was real. But the good thing that doesn't happen in reality, and you've never dropped 10 miles.
I've done it.
Okay, tell me when you dropped a 10-mile segment next to another one and it was wrong.
I don't have to go 10 miles. I don't have to go 10 miles. I can go 1 mile and see it. It grows. The error grows for 10 miles. It doesn't have to be.
Okay, all right. Real quick. We gotta elucidate this point, Phantom. The error. Okay, an error in reference to what? Your geoid? No, the GRS?
The error in reference to measuring flat versus.
No. What are you referencing to know that there's an error? You're talking about the GRS geoid model, correct?
Yeah, it's the geoid model and a.
So that's the model in question, right? A spherical coordinate system, right? That's basically transposed onto the ground.
No, it's not transposed. What does that mean?
Okay. You're talking about a spherical coordinate system because you're in reference. Like, what are you referencing for that geoid, right? The stars, correct?
We're not. Geoid is for vertical. You can throw that out right now.
Earlier, you said it was to make things simpler for other people. So you're taking the globe, you're transposing it onto a flat Earth. You said it was to make things simpler.
Yes.
Yep. That's what you said.
We take globe
so you could draw it on a piece of paper.
Well, you just deny that you transpose it onto a flat Earth. So I mean.
No, I didn't deny that. We take a projection. You understand what a projection is, right? We apply a projection to globe measurements.
What's globe measurements?
Latitude and longitude.
Okay, a spherical coordinate system. Jesus.
Well, okay. So what are you talking
about? In reference to the stars. That's what.
Exactly. So you reference the stars, and then you have to deviate the plumb line. That's objectively what you have to do.
GRS 80 doesn't have anything to do with the stars. Okay. The GRS 80 state plane coordinates. It's specific to North America. For deriving state plane coordinates. Okay.
State plane coordinates.
Yeah, and everything is tied down. We don't have to go. Like I said, we don't have to go back and to start a survey every day. I don't have to go back and measure the stars and recalculate and rederive the formulas.
Of course, that's not the point. The point is that you never did that, and you're assuming it's true.
There's a network of geodetic monuments all over the country and core stations, GPS core stations that are the same thing as a geodetic monument. Okay.
Isn't the point? The point is that
those are what we use to control these surveys.
Freaking out.
We put them onto a map and we connect from one side of the state to the other. It has to be all part of one consistent control network.
Yeah, that's right. We connect a whole bunch of plane surveys.
No, we don't.
That's correct.
We connect geodetic coordinates.
Well,
where did you get those from?
State plane coordinates.
Okay, state plane coordinates, and we're going to connect
them. Look it up
them.
in the Caltrans survey manual. Everything is done with the NAT 83. It's called NAT 83.
Yeah.
State plane coordinates, bro.
Yes.
Okay. You're assuming, brother, listen.
And
there's a model.
Projection from globe measurements. You apply a projection, and it translates that up to grid theoretical grid.
I understand. Okay, this is the point that we're trying to make to you. You're like, obviously, we don't go all the way back through everything each time and have to measure the stars. Like, of course, we're not even asking you to do that. Although it would be interesting to see you do it one time, is that you may be like, oh, damn. What? Okay. The point is that you're just assuming it's accurate. And what we're saying is that it's not accurate. And we're actually telling you how
You
it was
don't have any.
developed.
You have no way of saying it's not accurate. Have you gone
First
and
of
done the
all,
measurements?
you're claiming it is accurate.
You're making a
You should,
claim. You're making a claim. It's not accurate. I'm
yes,
claiming
and I
it
was
is because
explaining why. I was
I've
explaining
measured
why.
multiple times. I've measured all this network of geodetic survey monuments, and I've tied into other people's surveys, and we get the same results over and over. Everything
That
matches.
isn't in any
And if
way
you don't
mutually
apply these
exclusive to a
corrections,
globe.
the error is predictable. You get errors on it, and it's just you
You're
can check
saying
them.
that, but you've never done that.
Never done what?
Done it without assuming your globe model to give you your final like transformed
Yes, I
calculation.
have. If you measure between two geodetic points, you get an error, and you don't apply these corrections, you get a predictable error. That's what I keep telling you.
That predictable error is in reference to what? The thing that's in question.
It's like he doesn't get that.
Not in
He doesn't
question.
get
though.
that. That's
And I was
that's
every
the
time I
Not in
get
question with flat earthers.
almost to
You
the
guys don't understand
conclusion
how
of what's wrong with
concepts
them.
work.
Can you
yeah,
just
yeah.
trust me and give me a second? I'm just going to try to make this single point again. So yes, there's a spherical coordinate system. You have different ellipsoid models. You have a geoid model, ellipsoid models, whatever.
Yeah.
Okay, they use the stars. Like originally, the way that they're created, they use the stars, and they have a vertical. They establish a vertical plumb line, right? And that is perpendicular to an assumed plane, which is parallel to the plane of the Earth, or like a horizontal baseline parallel to the plane. Now, in the globe paradigm, that's vertical, right? And it's the same as a flat Earth on a local scale. But if you were to zoom out, right, it's actually just vertical down relative to the center of mass. If you were to put two vertical plumb lines, like
You're mixing stuff up though.
I'm almost done.
Vertical
This is
plumb
so,
line.
dude.
The vertical plumb line thing is for geoid models and for measuring elevations.
No, it's not. To even establish horizontal, you have your plumb line because you're going to establish perpendicular to that plumb line. So if I put a plumb line down and then I go 1 mile out and put another plumb line down on a flat Earth, they're parallel to each other. If I zoom out on a globe Earth, they're slightly tipped away from each other. Okay.
Right.
So when they made
That can be
made
measured
this,
as well.
you say that, but we know all about that too. But let's try not to divert. So they use the stars, okay, and then they have to deflect the vertical based on the model. And they built it with the assumed radius. Okay. And now what you're doing is having to transpose that onto a flat Earth. And you're saying, look, if I say, hey, now that I took this and utilized a flat Earth, if I go back and compare it to my assumed globe coordinates, it doesn't match. And
Oh
the more
shit.
distance I add, the less it matches. Of course.
Okay, so you're saying it's actually the opposite. The curve that we're pretending is fake. Everything was made up to deceive everyone, and
Wow,
the
that's
errors
totally what he
that we
said.
get is because the curve is fake and it's really flat, and I'm seeing the errors in reverse. Is what you're saying.
No, I'm saying you're trying to invoke using the Earth as if it's flat, as somehow it's proof of the opposite. And it's literally a measurement of a flat Earth. You have a globe model, you have to flatten out and then go use the Earth like it's flat, measure it like it's
No,
flat,
we
build
don't
on it
have
like
to
it's flat.
we don't measure it like it's flat. That's what I just told you. We measure it like it's curved, and we apply corrections to the
No,
deliverable and
you
the corner.
don't.
Yes, we do.
Wait.
You,
Absolutely measure it like
You
it's
just
curved.
said, hold
I
on,
just
wait. Before
explained
you even connect the 10 miles, right, between each geodetic point, as you said, how did you establish the first 10 miles? Horizontal line segments.
plane
Ah,
survey. You treat it like
yeah.
it's flat. That's why the survey manual says just neglect the curvature and treat it like it's flat.
There you go.
No, that's you guys are
Bro, you know what we're saying.
misunderstanding what
So
I'm even trying to tell you.
Dude, listen.
What
I
you
feel
mean,
like you would be a
guys?
good asset. You'd be a good asset, and you can actually test this out. Talk to your fellow surveyors. Talk to your coworkers. Okay, talk about this.
They're not going to talk about this. They're going to laugh about it.
no, they're gonna look around and see if they're able to talk about it without other people laughing.
Let me
So
ask.
I know lots of surveyors, people that own really big companies building highways, big civil engineering companies
Yeah.
all over the United States. Objectively,
So
they're flat
I'm
earthers.
a lay
No,
person, and I'm
you
asking.
don't.
I think I'm following along. So, I'm trying to understand both sides. If I understand the flat Earth argument is that this geodetic survey that we're referring to, that everything's
It's a
going
big
off of.
deception.
Well, that's a way of framing it, but basically you're saying that it's errored, and whatever the intention was. So they've got this reference of monuments and all this that builds up the geodetic system, and then he builds off of that system and then has to curve correct because that system has a spherical nature to it. And you're just saying that that system is false.
No. What he's saying is, if we take our globe system and then we flatten it just to make things simpler, and because it works on the small scale when you combine little
Right.
segments and it's negligible. After we make it, we stitch them all together and it gets longer, and then we turn back and compare it to our globe model, it'll be off. So we now have to correct it and transform it back to a spherical. Yeah, because they're
Right.
different geometries. One is Euclidean plane geometry. One is spherical geometry. They're fundamentally different. So of course they're not going to match.
Get are based
So-
off of the globe, though. We're
well,
not correct.
No, they're
That
based on a
begs- wait,
flat Earth.
Wait, I got an
Why?
idea. I got an idea.
Why? Wait. Why would they have a model that's based off spherical geometry and then correct off of that to flat? Why are these guys running off of a spherical model?
That's
could-
you know what? That's actually my question. That was going to be my question to Phantom. Why would you need to correct back to the geoid after you have your 10 miles like it's horizontal, it's straight, you know it's straight. Why would you need to correct it back to a geoid model?
Because the whole network of the highways needs to join each other from one side of the state to the other and not have a bunch of overlaps.
So you're pointing at an
Segment of
angle next
right-of-way
time.
mapping or each project length, you would have overlapping distances. Would be the main factor. And when we're talking about,
So are
like,
you saying
highway
that the
projects
next
or
segment
utility corridors.
you pour at an angle?
Right, like that's what you're saying, like off of the 10 miles, right? Oh, now the next one.
No,
You're
Oh,
gonna
if it's
pour
this much off, I
would
need to
show up
tip. I
in
need to
our it
tip
would
it
show
this
up in the
much so it'll
right-of-way
be at the right
mapping.
angle,
It
so
would
it doesn't
show- it would-
overlap.
it-
That isn't
it
what
would show up-
happens.
It would show up in the right-of-way mapping.
You just build another flat one and connect it, and then you say gravity does the magic.
The whole
And then
network
when you
has
look
to
at the
work
whole
together.
network, you put it in your freaking spherical coordinate system, and that obviously gives you a difference, and that's what you're calling a correction. It's a calculative correction based on a
it's not.
presupposition of the
Yes.
sphere.
No.
Yep.
it's
Okay,
not.
so that's my question. So why would they presuppose a sphere?
Because it's a
For their system.
philosophical bias, bro.
They believe the Earth's a ball. Like
There you go.
So they believed the Earth's a ball, and therefore when they set up their monuments and did all their measurements, they just laid out the world over a ball because they believed there was one. It's not because they're actually.
Yeah, and it goes back to how long do you want to believe the
No.
propaganda? If you go all the way back to the Greeks, they say the moon looks like a ball and the perfect shape's a ball, so the Earth must be one. Like basically what has happened.
How was Legrand's theorem of spherical triangles proven in 79? Was it?
Okay, I'm gonna finish my point. So this is a perfect example of when people are like, "Oh, you think all surveyors have to be in on it?" No, hell no, they're not in on it. Because what they do in the way that they're taught is they literally say, "Look, this is what the Earth is. It's a sphere. Trust me, bro. Okay, or we're gonna go over here in the real world and build things. We're gonna go over here in the Yes, that is true.
It's not
You're
true. You're just saying that. This is your argument that you've concocted. It's not true.
Dude, don't just sit there and say it's not true. If you've got a direct rebuttal, say it, but don't sit there saying
I
that
just
in the
said it.
middle
I've
of his
said it
sentence.
over and over again.
No,
We
keep
use
yourself on
curve
mute
models
unless you have
and
the
we
actual
use-
response.
The results that we get when we're using these curved globe models, taking measurements on the ground and translating it up to flat, or getting the results that we get, are not possible on a flat Earth. We couldn't apply
Oh
a
my
curve
God.
correction.
Oh my goodness, you
to
just
a
on
flat,
repeat.
Guys, going backwards. It's
flat
going around in
measurement.
circles.
and
He
get
said
the
you
same
couldn't apply a
result.
curve
It's
correction
impossible.
to a flat Earth. Like this is insane.
You couldn't.
So
You can't.
You know what?
You can't,
I
and not get.
let me-
You couldn't do
I
it
have
and
a
get
g-
the same results. You couldn't.
I
It's
have
impossible.
I have a good thing to add into this. I think you guys should discuss this. So you might be familiar with the idea that north-south roads often have to jog over some number of feet. And that the claim I've heard is because if you're mapping the roads out perfectly north, they're actually going to be going in toward each other.
Yes.
But what they do is they cordon off these roads. They want the roads to stay a mile apart or something like that. A certain amount of distance. They're gridded off. So as you're running these north-south roads, once in a while, it has to jog over to the left or the right. And I'll post an image of what I'm talking about in the side chat.
yeah, but that's just all based on a coordinate system. In the north, it would be the same anyway. Because if you use that coordinate system, it's just going to diverge out from the center.
No.
No, but it's.
What do you mean no?
that's the rectangular coordinate system, and they have meridians and parallels, standard parallels and standard meridians in every so many townships. They have to make a correction. All that.
Okay, and are those townships mapped out on a longitude latitude coordinate system?
Yes.
Yes.
Yeah, of
Okay, and
course.
does
They're
that
also
does that
but
longitude system diverge
it's
out as it
both.
goes away from the center?
So the meridians and the standard parallels are all done with latitudes and longitudes, but the township within itself is 6 miles by 6 miles, and it's done all with plane
Plane
coordinates.
survey, yeah, we know.
Plane
Trust me.
survey.
So the
So
error that they get from the plane surveys stacking on top of each other has to get corrected, just like Big Tech's talking
The
about.
no,
error. Okay. You keep saying the error that needs to be corrected in reference to the thing that's in question.
In reference to the geodetic survey model.
so you're
Right.
presupposing it as your proof,
Right.
and then you're
And you're
saying once I
saying that the reason
presuppose
the
it,
geodetic model exists is because there was just a bias in believing that the Earth was
no, yeah, they believe the Earth,
a
the
sphere.
sphere has been pushed for a while. Like all of
Yeah.
America was mapped out. Like George Washington, plane survey maps. Like go check them out, right?
No,
Like
it's not. They
he was a
use
surveyor. George Washington was a
those.
surveyor and never mentioned a globe, bro. He measured the Earth to be a plane.
No, the whole
No, is
more
that
than half the
true?
country was
Yes, George Washington was a
mapped out
plane
Be-
surveyor.
Yeah, but
using
how could we know if he never mentioned it was a globe? It would have to
I'm saying
stand
in
to
his
everything he
actual
ever said.
maps and measurements, there's strictly plane survey.
because they're
And
small
I know
enough
it's true because I went and looked at them.
you can ignore the curvature.
Yeah, that's right. We can ignore the curvature.
That's-
Hey, do you agree that if
There
the
you
Earth
go.
was,
they had
hey,
at that time, the error that you get and the size of the survey they would be doing is negligible, or it's not. It's the instruments and the methods that they use would have more error
you
than the
keep
actual error
saying
you would
error
need
like it's a real
to
life
measure.
problem, but
It is a real life problem, though.
it's a model calculation problem.
It's not, because there's other ways you can see it too. If we go out and do
This
leveling
guy.
and we
Who
don't
is this
apply
guy?
correction formulas, you'll accumulate an error. As the further you go,
Oh
you'll
my
keep
goodness.
accumulating an error by not
You're just going to keep
predictable
saying error
not
in the air. What is the error exactly? What is the error?
if you don't apply the correction for curvature, because when we're sighting through an instrument, for example, on a level, you're sighting, like you were mentioning earlier, a horizontal line goes out into space. It doesn't follow the curve. But when we're taking a reading on a rod, it's on the ground, so it's leaning away from us, and we're seeing higher on it than it actually is on the ground in relation to the curve. So we have to make a correction.
In relation to
The
the what?
ground. In relation
No,
to
how
the
do you
No,
ground.
no,
get
no,
your
no.
error? If
But
you're,
Yeah.
if you connect, if you do what's called a closed loop, and you take measurements and you don't apply this correction, you're going to accumulate an error that's
okay,
predictable
how do you
throughout this
determine
network
the
and get
error?
closed
If
out.
I want a number, I want to know what my error is. Don't give me a number. I'm saying if I want to find a number
You
of what
start
my error
with an
is.
elevation. So in leveling, you start with an elevation, whatever it is. It's an assumed or it's a known elevation. You start with that, and you measure. Basically, you're measuring plus and minus, plus and minus. You backsight plus, foresight minus, and you move ahead. And you're transferring an elevation as far as you need to go. I mean, you can go hundreds
Yeah,
of
which
miles
is a
like that.
distance
And you
vertical
close.
relative to the horizontal baseline.
No, it's distance. It's a distance up from the ground.
Yeah,
You measure
elevation is
from
a distance above the
The ground.
horizontal, vertical.
yeah.
Ooh,
Distance,
I got a
it's
really good
altitude.
question.
Go ahead.
This is going to be clarifying. Check this out. This is hypothetical. I want you guys to both answer and see if we agree. So we've got a theodolite, and we have a scenario where we're taking refraction out of the equation. Okay, assume no refraction for this thought experiment. We're on the Earth, and we are taking from a theodolite. We're on a platform that's 50 feet in the air, and we're taking a perfectly horizontal optical measurement out. We're looking out horizontally perfectly.
Mhm.
We're looking at another tower that's 20 miles away. And that tower is perfectly vertical.
Mhm.
And we're 50 feet up. We're looking out horizontally at a tower that is also 50 feet tall. It's 20 miles away. Are we going to see the top of that tower? Are we going to match up like, are we going to see a target that's 50 feet in the air, 20 miles
You're
away?
going to be shooting over the top of that target. Assuming
That's what
they're
you
at
say.
the
You've never
exact
done anything
same
like that.
elevation.
Like, no. Objects change angular size in the distance.
Yep.
And we don't use things like theodolites over 20 miles. That's insane. But
Okay,
what
but it's
if,
like a
well, I want
telescope,
to,
though.
well, check this out. No, it's not. But check this out. If
No,
we
the one
were,
I'm saying, we have a telescopic
just think about this,
theodolite.
bro. I'm gonna be like,
The
okay,
total
you
stations
said you would
exceed
take refraction.
30,000 kilometers.
When you say let's just take
30,000?
refraction.
Total stations.
Dude, that is okay. Oh my God.
Which is
When
the
you
same
say
thing as
let's take
satellite.
refraction out of the equation, right? If you actually do that, which I've talked to many geodetic surveyors about it, if you actually take refraction out, on average, you see that the Earth, if you assume it's a ball, is on average 20 to 25% too big. Meaning that where the curve should be, the effects of the curve should be seen on average. You see 20 to 25% further than that. As if
Now,
we're still horizontal.
I just want to acknowledge, I asked the question, he gave me a straightforward answer, and you didn't give me a yes or no.
What?
Witsit did not answer the question.
What are you talking about?
He
Well,
said
no,
we would shoot way over the top of it, and Witsit said, I don't know what
He
was
said
Witsit
things in the
answer?
distance change in
change angular
size.
size.
And
So would we
angular.
see the thing 50 feet up if we're shooting a perfectly horizontal view? Would we
Level
see the
line.
top of the thing?
No.
Yeah, yes. In a world where somehow there was no ammo, yes. In your paradigm, it'd be tipped away from you a little bit, but in reality, it'd be parallel to you. But the problem is, we don't live in a world without an ammo. And what I'm saying is, if you actually do geodetic surveying, right, and you assume no refraction, it's abysmal. Like this guy told me that sometimes his measurements would make the radius like 27x.
That's yeah. And this has been an argument too. It's
why
like
wouldn't-
either
why
Earth
wouldn't
is
you
so
assume
big
refraction?
where it looks flat.
Why wouldn't you factor in refraction though, when we know refraction is empirically measured? We know.
Wait,
it's
how do you
there. Why
empirical?
wouldn't you factor
Okay. Before we get away from that, this is the point, man. This is just the truth. Okay, it took a long time to build these different geodetic survey models, and the way that they did it, right? Where they took all these plane surveys, and they're like, okay, all of these work really well. We're able to very accurately map everything, build runways, railways, bridges, all that. Just assuming the Earth's flat, but we quote unquote know it's a globe. So what we need to do is zoom out, stitch it all together, and we need to fit it into a model of the globe. Okay? And it took them a long time to do it, lots of corrections, and they used the sky. So how you see the sky based on where you are, how it drops down based on where you go. Then they started deviating the vertical. It rarely would actually match. So you have an entire like randomized arbitrary fluctuation of vertical. Then they developed this spherical coordinate system. Now they give it to you and say, this is where we live. You're about to go do a more local project, flatten it out, just neglect the curvature. And then at the end of it, you're like, wait, so we treat this whole thing like it's flat. If I think it's flat, here's the difference between that and what the globe model would claim for. And you're just calling that difference an error. Now, there's no actual error. You can go use whatever you built. In reality, it works perfectly fine.
No, it doesn't.
It
I
works
just
perfect.
explained that. I just
You
explained
didn't
that.
give one
So
example of it not.
I just did. If you go far enough, so when we do the right of way mapping for highway projects, they all join. Everything has to join together. Everything has a state plane coordinate on it. A state plane coordinate.
Plane.
It's derived using a projection that's based on NAD 83 coordinates. A geodetic model of latitude and longitude coordinates.
That's our
GRSH.
point.
Okay.
You're literally
So-
saying the point that we're trying to make.
No, you're not. No, I'm not saying the point. You're not getting it.
Oh,
You keep trying to go state plane, blah blah blah, whatever. Oh, it's a plane. We make corrections to make a deliverable, a final mapping deliverable to the engineers and the mappers. That's a plane, a theoretical plane, but we have to apply all kinds of corrections to get to that. Okay.
yes, because if you
If we
assume the
don't-
Earth's a sphere, then you have to make corrections because it would be different. But it's not that you're doing anything in
not that
reality that's different. You're just trying to match it
try
to
to
the
join all these measurements across the whole state together as if it was a flat plane without these corrections, it would all overlap. These maps, these right of way segments would not fit each other.
It would
And
overlap.
yes.
How would it overlap? In what way?
Because the globe, the measurements you're taking over the globe would not fit on.
You're saying
a
it's the
flat
opposite, bro.
theoretical plane.
You're saying
Why
it
not?
literally the opposite.
Wait, why not? Why not?
Either way, it works.
Oh,
The
now
distance
it
along
works
a
to be
curve.
flat.
No, the distance along a curve between 2 points is longer along a curve than it is between as a straight shot
You're
between the 2
making
points.
incredible flat Earth arguments because although that is geometrically the case, in reality, it doesn't actually have to be physically accounted for when you build things.
Exactly. It's
Yes, it does.
negligible. That's the
Well,
point.
I mean,
That's the
not
flat Earth
proof of
argument.
anything. Yeah, because the difference in the distance is everything's built in these small segments. You know, there's
Here,
like I
I'll-
said, a concrete pour is
Dude,
wait,
500
just
I'll
feet,
cut it.
listen.
200
Think
feet.
about
I'll
what
cut
we
it down.
talked about. You're a flat earther, bro.
No, I'm
Yeah.
not.
Okay,
I'm not
alright.
a flat earther. Just because things are built in small segments and within small segments, the curve correction is negligible. Does not
Negligible.
prove the Earth is flat.
You
So the only time
claimed,
you would
though,
need
that it
it
would
is
be
to fit it
different.
back on your geoid. That's the only reason
Exactly.
why you have errors. Is because
You
you're
keep trying
trying
to
to.
present it like you couldn't even build the stuff and it wouldn't work if you
It's
didn't do it,
if
but
you
that's
try
not
to use
true.
plain methods and stretch it across the state, these big segments, they would not fit each other. It would
You
not
just
fit.
keep repeating that,
Just
then we ask you why, then you
you
turn
keep
back to
repeating
saying
what you're
it's the
saying though,
same. Oh my god.
because
Yeah,
I'm
but
repeating it
Phantom,
because
you're
you're
not
not getting it
listening.
and you're misrepresenting what I'm saying.
Geo-
You're trying and you're lying and saying that there is no measurement, there is no correction, whatever. You can't prove that. It's not. It doesn't show up in things that are built. I'm showing you where it does. I'm telling you where it does.
No, because
These
you say
right-of-way
it
maps
won't
are
work, and I
property
ask you
maps
why.
that people's property is especially along the coast. It's valuable. Even a
And
small
flat.
half a foot, whatever, it makes differences. So people's property lines have to be in the right place. These right-of-way maps for Caltrans are are joined by property line, private property, whatever, public property, but they're tied into the network of property lines throughout the state. So all that has to be accurate and correct. So these maps are all geodetically referenced, and
All right.
the projects are correct. All the projects are corrected. Basically, what I'm telling you is that we're out laying out these highway projects in grid, is what we call it, and
Mm-hmm.
even though they're being built on the globe, and they're able to ignore
Oh my
the
God, land
correction
the plane.
because you're pouring concrete 100 feet, 200 feet, whatever at a time. So the difference in those small segments doesn't add up. Where the error would show up and be a problem is if you go
Is when
10,
you do
20,
it.
30
You do it
miles.
geodetic. Yeah, that's our point, bro.
The maps wouldn't join up with each other, and you would have errors in people's property lines and,
All right.
the takings of property lines along these right of ways when they acquire new right of way and all that stuff.
Ho-
The whole network from one side of the state to the other has to
Phantom.
fit together without errors. We can't
Let me
have
throw you a
errors.
bone.
It's not
Let me throw you a bone
acceptable.
real quick, bro. Just let's forget about the geodetic reference point, okay? You just made
I don't know why.
these horizontal line segments one after another for 10 miles. Now, they're correct, right? Because you did it segment by segment. Right?
I'm not
Right? You
following.
finished. You're done. You finished. We did it, guys. 10 miles. It's done. We connected all these line segments together. Would they measure flat
Yeah,
for those 10 miles?
they do, of course. So it's
Hold on,
mapped
wait.
flat.
Let him answer. Let him answer. I got you, Roots. I want
It's so frustrating and simple though. But carry on.
but it's an important cog this point though. So Phantom, would it not be flat for those 10 miles? Forget about the geodetic reference point afterwards.
Would what be flat?
Those straight line segments that you made one after another from up to 10 miles.
No, they would wrap. It would be small segments of, say, if we're using, I don't know what you're talking about, but if GPS, we don't have to survey it in small segments. We can go farther. If you're talking about a total station or a theodolite measurement, we
Dude,
would
I'm
have to
going
do
by
that
what you said, right?
in short
Horizontal line
segments.
segments, right?
The horizontal line segments, we would generally do
Up
that
to
in
10
800-foot
miles.
segments. So it would be basically pretend you have a curve and you have 800-foot flat segments placed one after the other along the top of this curve. That's what it would look like.
Hold on. Forget about the curve. Don't assume the curve. Okay? We're asking you not to pre-assume that. That's our point.
Good luck, beast.
This is insane.
But it's important though because like this guy works with surveying shit all the time and it's like, bro, I guarantee you, Phantom, if you just like forget about the stigma or the dogma of like being a flat earther.
I hear the bad faith argument you're trying to make.
I'm not making a bad faith
It doesn't
argument,
matter
bro.
how many times I repeat it. Yes, I mean,
I'm all right. Just a clarifying question: is it straight, a horizontal, right? A horizontal line segment, 10 miles, right, one after another, without referencing any geoid? Is that flat for the 10 miles?
No. I mean,
Yes.
How?
I mean, is that flat?
Is it horizontal the whole time? Because you just literally made it segment by segment horizontally.
Yes, you established that with a tangent plane. Just answer the questions.
I mean,
What elevation change did you measure over 10 miles?
0.
yeah, because
None.
level is in relation to the curve, though.
What about the other guy who did the survey?
What curve? No,
How much
look.
elevation
The
change
point
did you
is,
measure over 10 miles?
you're mapping. You're not getting elevation change, and I've been trying to say this just to back up what's been said already. You're mapping it flat, assuming a sphere, and that's where you get your diverging zenith angles, like Witsit said. Without
No,
your
we all know
EC,
how
without
we all know how
no,
the
let me
measurements.
finish.
Well, let
Let
him
me
let him
finish.
finish. Let him
Let me
finish.
finish. You claiming that there are diverging zenith angles, yeah, is the pre-assumption because, as Beast is demonstrating, we're not measuring anything but a flat plane with a tangent plane in respect to that tangent plane being parallel to the surface. So there is no way out of
I've
this for
already
you.
explained it.
You're in
You're
cognitive
wrong.
dissonance, my
You guys
friend.
are just not picking
Pre-assuming
it
is
up.
not
You're in
proving.
denial.
No, you're
It's
using
not pre-assumed.
ECEF coordinates to take flat data and map it into a sphere based on a pre-assumption. Congratulations, you're in a religion.
ECEF coordinates are not flat,
You
though.
were slandering religion earlier, but you're in a religion.
ECEF is not a flat coordinate. It's still, that's a globe model.
Earth
More
center, Earth
evidence that you
frame.
didn't
That
understand what I
was
said. Yeah,
his
you just don't
entire
understand.
point. Yeah. That was
Yeah, so
literally his
you
point, bro.
the thing is, in order to address Phantom, in order to engage with these guys, what I hear you doing is insisting that since the model is curved and it's spherical, then the Earth must also be spherical. And they're saying no, just the model's spherical. And so the errors that you have are in relation to the model, and they're saying
Correct.
that the model's wrong because it just presupposes the globe.
Exactly.
And what they're
Great,
saying is
Steelman.
you haven't gone yourself to confirm everything about how the model was made and all of the coordinate system that you inherited in your training. You're mapping off of that coordinate system, and they're saying the coordinate system is bogus.
That's what's in question. That's what's in question.
No, and
because
we have surveyors that have gone out and done it and they become flat earthers. And that's why when he asks you this question specifically and he says, so if we just do 10 miles of like small line segments horizontally and we connect them and we're done with the 10 miles, do you agree that those 10 miles would be horizontal?
and level and flat.
No.
Yes.
No, I don't.
Was there any
Come on, guys.
elevation change measured over 10 miles?
No, it's dude. If you're going from one segment to another, all right,
Are
this
they
is
shared
aligned
segments
with
or
this
the same
segment.
segments? Oh, yeah,
He
but are
just
they the same set? Are they the same, or are they shared line
So
segments
Phantom, what you got to do
at
is you
different
got to come up with
elevations?
a demonstration of something that's outside of just relating to the coordinate system itself. You have to demonstrate, like in this project here, if the Earth was flat, this project wouldn't have worked regardless of the coordinate model system. You have to say, like, this wouldn't have matched that,
it
and
does-
here's why it only works on a sphere.
But that's the thing. There is no example of that because in order to assure that your building is straight, guess what? You have to make it straight and level.
Large
And then
hadron
when you're-
collider, the large
and then
hadron
when you're-
Because it
collider,
already
they
Hold on,
isn't.
wait.
Because
Hold on,
it
let me
isn't
finish
already.
real quick. Phantom. So
Because it
when you
isn't
say,
already,
but
you mean.
when we apply the right of way mapping, correct, right? Like for a highway, when you apply certain references, right? Like a geoid or an ellipsoid or some other type of mapping that's connected to a larger geodetic system, that's when you're going to have errors. And that's our point, is that in reality, you wouldn't have those errors if you don't reference the geoid. The only reason why you're referencing it is because that's how you were trained.
Okay,
Checkmate.
Basically, what your guys' argument is that I have to go out and prove for myself that these models are not a hoax, and that all the
and you'll find
geodetic
out that the
control
Earth is
points on the
flat.
ground,
Yeah.
even though we measure between these passive monuments that are on the ground that have geodetic values, that those are also all a hoax. Everything's a hoax.
Not
Geodetic
being a hoax, it
values.
just assumes the thing in
Latitude and
question.
longitudes, and we get, you know, the results we get fit with the globe models, the measurements that we
They
take on the
don't.
ground,
You have to
even though
change them drastically.
No, we
All you
don't.
have to do is make no assumptions.
We don't have to
Yeah.
change them drastically.
Yes, you do. That's how it was
Yeah.
built. I've looked into all of it, how it was even made. You look, took drastic corrections
No,
that didn't match
that's already
reality.
those corrections are already built into the network of control that I'm talking about. There's a
Yeah, because I'm talking about how
H-wise-
that network of control was created.
Created in the first place. Yeah. How was it created in the first place? Plane surveying.
No,
And then
wasn't
they
plane
stitch it
surveying.
together, and then they apply an overall
You guys even
curvature rate.
admitted it uses celestial observations. They use the transcontinental survey. They used all kinds of globe
The
measurements.
transcontinental survey was just
by definition, that's not plane surveying. They did
that was
not
just an example of them trying to stitch the plane survey together to match a presupposed ellipsoid model. And if you actually look through it, it took tons of corrections, tons of assumptions. Half the time they couldn't even see what it is that they were connected.
But the raw data angular measurements produced more than 180 degrees.
That isn't true. We looked through those. Some of those are below 180. There's a ton that are 179, right at 180. So what about those? And the way that they get over 180 is actually put it in the spherical coordinate, adjust it for the celestial network, and then say, look, it has to be over this much based on that distance on this globe.
So let's correct it back to the idealized celestial sphere. Boom.
And now you have that, and you go use the Earth like it's flat, turn around and say, look, this other thing that presupposed the globe, that gave me the model, that's allowing me to presuppose the globe, doesn't match when I don't presuppose the globe. So now I need to correct it back and pretend somehow it was what helped us build it, even though it was literally a flat Earth measurement.
So the guy that was
I don't, no. The transcontinental survey. There's been
geodesic.
Hold on, someone's trying to get in, but I think you're cutting out, bro. But go ahead.
No, I said, so the guy that was wrong about the sun in Antarctica is trying to correct somebody on geodetics. Interesting.
Yeah, that's just called an ad hoc. Trying
all
I
right.
don't know,
Red herring,
make it
non
past third grade
sequitur.
or something.
Yeah, you haven't even
Yep.
been here for the conversation, dude.
Yeah, never mind.
Sit down.
Poisoning the well.
Back to Phantom. Phantom, go ahead.
Because this is the
wouldn't
part that
measure-
we're disagreeing on. It makes no sense. If I connect small horizontal line segments for 10 miles, okay? If we zoom out after we've completed the 10 miles, do we both agree that that 10 miles is horizontal?
No.
Was there any elevation change?
It's just
measured over
cogdis,
10
man.
miles?
It's just
It is
cogdis.
cogdis at this point.
Yep,
Yeah.
that's all.
The
It's just
elevation
that
changes would
you're
describe the
taking
surface,
measurements you're taking flat measurements, because the instrument can only measure in a straight line optically if you're talking about a
There you
theodolite or a
go.
total station. Okay,
You're
so
Flat
proving our point
measurements.
again.
let me finish what I'm saying.
So how would
You're
it somehow
saying
not be
because
horizontal?
of that, and because we've stitched this together, that automatically means it's flat. It's impossible that it could not have been
No,
done
what
on a globe.
What I'm saying is that you keep saying no to the question, but it is objectively yes, right? Like if I take small horizontal line segments and connect them together with a measuring instrument that can only measure straight lines, and then after I complete the 10 miles, if I zoom out and ask you, hey, is that 10 miles horizontal?
Yeah. So I explained this earlier. A measuring instrument that can only measure straight lines is called a level. Okay.
Right.
If you level for a long enough distance, you take off from a known elevation, you're transferring plus minus as you go. You can go as far as you want. You loop back and you close out to your starting point. If you don't apply those curvature corrections, the error that you get, you should if everything was done perfectly, when you check back into that starting point, you should be flat on top of it. But
It's really baffling.
the error, there's different sources of error, but one of the sources of error is curves. And if
You just keep saying that.
you don't apply that curvature correction, the error you get when you close is predictable.
The error is predictable because the error is in relation to the presupposed spherical model.
It's not. It's in this case, it's because you're measuring a flat straight line when you're actually on a curve. So that and elevations are in relation to level and that conform to the curve of the to the curved surface.
No, we measure a vertical distance perpendicular to the horizontal.
So this is how a level measurement works. You're looking at a flat line. on a rod that has a series of numbers on it that starts at 0 at the bottom.
Survey
and
markers,
counts
right?
up. No, this is a level rod. Differential
rod,
level
for sure.
rod is what it's called. Okay, starts at 0 at the bottom where you take your shot on your point when it'd be a turning point is what we call it, and it's in feet. Well, the way we do it in feet or whatever units you're using doesn't matter. So you measure from 0 up to wherever the crosshairs hit the rod. Okay, that's how the measurement is taken. You start off of a benchmark. You measure up,
Horizontal.
and that's the height. That's the height of your instrument, and then you measure to it. That's your back sight, and then you measure a foresight, and you keep leapfrogging ahead. The foresight you subtract. You just keep transferring elevation like that. Okay, when you're sighting that rod, you're actually seeing, depending on how far the shot is, especially, but regardless, it just grows as the further out you go. There's more curve. It's falling away from you. So when you're sighting that rod, you're seeing actually higher up on the rod than what the actual elevation is on the surface. So if you just leapfrog and do a big long run, what we call a level loop, start off an elevation and close out at the end. If you don't apply a curvature correction, there's a predictable amount of error that you will see when you check back into that starting point. If you apply the curvature correction,
the rod is plumb and
balances
vertical,
out.
isn't it?
No, I think that was pretty good because he didn't reference the geodetic model at all.
This is a different.
You're talking about
model.
shooting from rod to rod, right? One leveling rod to another leveling rod.
No,
Now you're saying there's an
you're
error, a
you're
predictable
shooting from the
error,
instrument to a leveling rod. You're taking
an instrument to a leveling rod.
observation. You're sighting it.
Now that leveling rod is what? Perpendicular? Right? It's
Yeah,
plumb?
it's plumb. You hold it plumb to the, yes, you hold it plumb.
Right. Now you shoot it, right? Boom. I go back, what, 100 meters? 200? What's acceptable for you? And you're actually, like,
Depends what type of
like your boss is like, dude, I need these to be shot right.
130 meters.
130 meters, right? Why?
You can go further.
Why can't you go further?
Because
What?
we use that to balance out the air. We can go further though. That's what I'm saying.
But you can
stretch
go further, but why
stretch
is
these
it not
observations out.
recommended?
You can use
But
more powerful instruments to take longer shots to eliminate the number of setups that you have.
Yeah, well, we'll just answer the question real quick. Why can't you go further than 130 meters, respectively? I mean, you can, but the reason why you don't is because it's not as accurate the farther you go, right?
Yeah, it's to do with the other errors that are factored into the types of
right. Not just curvature, according to you, but refraction as well, right? It's a CNR correction, correct?
Right.
Okay. Now, let's take out curvature for a second. Let's just say it's just refraction. Now, how can you differentiate between refraction error correction and curvature error correction? See what I'm saying? They're conflated.
They're combined together. No.
Exactly.
They're combined together. If you only apply one of those, you're still going to have an error from not applying the other one.
There's no way to separate it in the way it's built. You know that. It's C and R.
No, yeah, right. Every time you take a sight observation to an instrument, you have to apply a refraction, correct?
C and R, right. So what's in question?
Always there.
Yeah, what's in question for us, right? We're questioning the curvature. Okay, we're not questioning refraction. We're not questioning optical effects that happen over long distances through optics, right? Like that's why theodolites, have a plus or minus margin, right? Sometimes you can measure concavity or convexity, correct?
Concavity or convexity, no.
Sometimes it looks like it's higher. Sometimes it looks like it's lower in terms of the thing you're shooting at, depending on the atmospheric effects, right?
Yes, that's possible, yeah.
It's potential, right. So now that we established that, we're trying to verify the curvature in the first place, right? Now, without presupposing the curvature or the geoid or the ellipsoid model that you're trying to basically match, right, with these straight line
these models, it's just the curvature. It's just the Earth.
Hold on. We're just talking about you're shooting from one spot to a level rod, right, with the instrument, and you're going from segment to segment to segment, right? Now, what you're saying is even those small line segments, right, you're applying the CNR button, correct? Even on those little lines, right? Even though it's just a little short distance, you're still applying that button.
You can apply it in the field or in the office, or you can do it manually on paper. It's
Not on an auto level, though.
different ways you
Is it
can
using
apply
an
it.
auto level?
An auto level just means that it automatically compensates itself. The crosshairs automatically compensate. That's all that
So
means.
is that what you're using over 130 meters? Is that the tool you were using?
Yeah, what are you actually
Yeah,
using?
I mean, that's like the shortest range type of level that we use, because
So that's
as
the
we all
tool you're
know,
referring to, the
generally
auto level.
we don't.
Just to be clear.
For geodetic surveys, I'll say it again, geodetic surveys, they also use, they do long range leveling, first order leveling.
What tool are you referencing
but-
here in what you're talking about?
But we're not trying to go to geodetic, bro. We're just using plane surveying because that's what is being used to establish these straight line segments, these horizontal line segments from one spot to another, right? We're just using plane surveying. Because what happens, according to you, right, is when you apply the geodesic reference points, right, between the 10 miles, right?
There's no geodesic. I'm talking about leveling. This is one dimension. This is the z-axis. We're just
Okay,
measuring
cool.
elevations.
Okay, cool. Yeah.
All we're doing.
And you're trying to make it level from one segment to another, correct?
Right. We're trying to transfer an elevation from a known point
Uh-huh.
through a bunch of a network of points, and then come back and close out back to where we started.
Through horizontal line segments.
Correct. Right? Horizontal line segments.
Yeah, it's not. You're talking about horizontal. When you tell me horizontal, that means X and Y, or latitude and longitude. I mean, we're talking about
isn't that what you're establishing from your point to the
two-dimensional coordinate? When
pole?
you say horizontal, you're talking about a two-dimensional measurement. When I'm talking about right now about leveling. Leveling is one dimension. We're just measuring in one dimension, the z along the z-axis, elevation only. So
elevation only, z-axis.
It doesn't matter. When you're saying horizontal, that's when you're saying horizontal, I'm talking about looking down on a plan view, two dimensions, x and y, to make it simple.
Okay. Well, the reason why we brought up horizontal is because you were talking about a highway, for example, correct?
Right.
Okay. And it's horizontal line segments, one after the other, from one point all the way to another point that's 10 miles away, but in between, you're connecting line segments 130 meters apart, respectively.
No, generally that's not the way we would do it. You're mixing up the two different concepts I was talking about. I'd have to get you an example of some first order leveling that's long range.
I'm down, dude.
How far they make the observations.
I'm down, dude. I just want you to understand our point. Yeah, he's a surveyor. So I just want you to understand our point is that without pre-assuming ball, we're just measuring horizontal line segments one after another.
Yeah, there's
continuously.
Horizontal line segments. You keep saying that. And I'm telling you, I'm talking about leveling right now. I'm not measuring any horizontal line segments. All I'm measuring is the vertical distance up from a point to the crosshair on my level instrument. So I'm measuring the vertical difference from a benchmark to basically a transfer point. So we're
basically making it zero elevation, right?
No, we're just whatever it is. We're measuring it, whatever it is. We're taking a measurement on it, and whatever the results are, we're not trying to force it to be anything. No, we're taking off from a known elevation, and we're transferring that through a network of points, turn points, and then onto other control points or wherever we need to transfer that elevation to, so that everything is relative to the same benchmark elevation.
Right, that benchmark elevation, your 0 point.
Yeah, whatever you want to call it. It's
okay, that 0 point, you're trying to keep it, your starting point, right? So you're going from point to point, right?
Yes.
And you're basically trying to make sure that it's 0.
No, we're not trying to make sure it's 0. This is where you get lost.
Okay, what are you trying to make sure to do?
Go on we're trying to measure what the elevation difference is from that starting benchmark point to the next point and the next point and the next point.
Why?
Because that's how these projects are designed and built. That's how. But why are you doing it like that from one point to another point?
But why are you doing it like that from one point to another point? Why?
Because that's how we know.
But why are you doing it like that from one point to another point? Why? Because that's how that's how these projects are designed and built. That's how
That's how the measurement's done. That's how we
To make sure it's
transfer
level?
elevation. No, to know what the elevations are.
Why do you need to know the elevation other than to know that it's level?
To make a map with elevations on it so we can give it to engineers to do design on. They need to know what
whether it was curved or not. But you measure the elevation changes, isn't it? Know what the surface is.
Yeah, again, this is where you guys get confused because the elevation changes are measured along a z-axis. Okay.
Okay.
Yeah, they're establishing the topographical change.
Okay. Now I want to make a highway. I want to make sure I'm pouring concrete like you said, 500 feet pour, 800 feet pour. I want to make sure it's straight and level. I don't want to drive on a curved ass road, a bumpy ass road, right?
Right.
Okay.
So you go level in
segment by segment, correct?
Right.
Okay. So it's level.
Level is measured perpendicular to the curve.
I'm curious.
Measured along a plumb line. It's measured along a plumb line perpendicular to, you'd say the curve, but it's basically perpendicular to the center of gravity.
You say the curve, but it's just the center of gravity, which is it's exclusive.
Right, what I'm telling you is if you go far enough, if you're doing those level measurements and you're using what we call an instrument called a level, that the error from that you get from the curve is going to accumulate because you're not actually measuring a curve when you're sighting it. You're measuring a straight line, and it's showing above on the rod.
So what happens when you close it out?
Rod, what the actual elevation is.
What happens when you close that out, that loop?
That's what I'm saying is if you go far enough and you close that out, you're going to get a difference. If you started with, you assumed elevation 100 at your starting point, you're going to have, depending on how many turns you did and how far, it depends on the length of your level run, but depending how far you go, that error is going to get bigger and bigger. So when you close out, I don't know, you could end up with a couple of tenths or inches. You want to say in inches, we work in tenths and hundredths. So it'd be tenths,
so you're
half
talking
foot error, depending how, or more, depending how far you go.
So you're talking error as when you close the loop, the error you're talking about that can accumulate is the error that is really that correction that you're going to make when you go geodetic, right?
Well, the error that we see, we call it a closure error. So what we're doing, if in this case, I'm talking about leveling, we're doing pluses and minuses. So we have a starting point, and we measure out. We take a rod, we measure how far up off of that starting point we are in feet, and that gives us the elevation of our crosshairs. Now we know what the height of we call that HI, height of instrument. We know what the elevation of the crosshairs. Now we do a foresight, we transfer that to a new point, and we keep leapfrogging ahead. When we shoot the foresight, we subtract. So we're taking our crosshairs that we already know the height of because we measured up from a benchmark. It's easier to show this to you guys on a diagram if I had. And that now you're taking, you take a foresight, now you're subtracting that. So we're just adding, subtracting, and we're transferring this elevation that we started with at the benchmark around through a network of points, however far we need it to be for the size of the project.
Right.
Or if it's a giant control network, whatever it is. And then we close back out to where we started from. When you close back out, whatever you start, you can break down all your measurements. And at the end, if you started with the benchmark being an elevation of 100, you should theoretically, if there was no error and everything was shot perfectly, you would close back out to your pluses and minuses, and the last elevation you would get on your check-in shot back onto the benchmark would be 100 when you add and subtract all that up throughout that network.
Right. So
what I'm saying is
zero deviation, right, from your original benchmark, aka level.
That's if there was no error. What I'm saying is you're always going to have some type of error. There's various types of error, but one of those types of errors is curvature. And if you don't apply the curvature correction, you will get a predictable amount of error when you close out based on however far you've gone, based on the curvature formulas. It matches. So that verifies all these measurements that these guys have done over the years to develop these models and whatever that you're saying that I haven't gone and re-derived them on myself. So I don't know if they're not some.
Well, do you know how these geoid models were made, bro? Like the WGS 84.
I'm not talking about those right now. I'm just talking about leveling and curve correction.
I'm just asking you. I'm just bro, I'm just asking you, how are those geoid and ellipsoid models created in the first place? Do you
Tons
know?
of different types of measurements and tons of math and
Yeah.
massaging it.
What was the first one? The first big one, specifically for the WGS 84.
It would have been some type of celestial observations.
And plane surveying.
Yeah,
right?
it's verified
The great triangulation.
Yeah, but the triangulation is not plane surveying. That's just turning angles between reference points. You're setting up an instrument. You have a target. You measure the angle from where your instrument is set up, from the first target to the second target. You're turning angles. That's all you're doing.
Okay.
So all those little triangles that are created, that's not a planar survey?
No. That's not
Your
How's
pluses,
that?
your,
That's crazy, dude.
Your pluses and minuses are elevation change. You're looping back to the start point is to verify the that you've kept to the
verify
benchmark
the closure to make
from beginning to
so
the
we can
end
see
and
how
back
much
again.
error. Yeah, to see how much error we accumulated throughout that run.
Well, the error is elevation change.
No, the error is.
That's the difference.
No, it's not
The
elevation.
benchmark is.
The error is not elevation.
You kept the integrity of the benchmark from beginning to end and back again. If you confirm it.
Yeah, but we do that
then you've transferred that same benchmark over the distance and verified it by looping back. And the pluses and minuses that you are taking into consideration are the elevation changes from that benchmark, up and down.
Okay. Yeah, it's the correct, but that's
Yeah.
not the error. That's not
So
the closure
from continuous
error that I'm referring to.
straight line horizontal segments, that's your benchmark. You're measuring an elevation change, plus or minus, and then getting a picture of the surface.
Right.
So then you got those.
And then you know how
those
to
corrections.
actually, make a level horizontal road if you wanted one.
Correct.
You're going to have to put it on stilts, or you're going to have to drop it up and down. But that would be in reference to the horizontal that you'd established.
To the horizontal.
But that's got nothing to do with the surface.
Yes, it does.
And the surface is what you need to measure.
The measurements that we're taking.
The measurements we're taking. What is the surface?
The measurements that we're taking when we're leveling are in relation to the instrument and the leveling rod. That's it. I mean, there's not. Yeah, it's on points on the surface. So I don't. You guys are misunderstanding what I'm trying to tell you. It's the error that we get when we close out is not based on elevation change. It's based on errors that are accumulated, systematic errors that are built into the, we have instrument error.
There's an error in every one of your transitions. Is that what you're saying? Every transition that you verified is horizontal.
Every measurement you take
through
has some small amount of error.
And looping back, they all have an error.
Yeah.
There's no instrument on the planet of any type of instrument has zero error. Every instrument has some
of course.
Of error.
It's measurable though.
Yeah. But see the thing is, right? What Globers will say, and I'm not saying you're like a Glober like that, but you are obviously, but I'm just saying what they will say is each line segment, 100 meters or 130 meters respectively to one another, will have such a minute amount of curvature and refraction, right, that it's already accounted for. But if you connect a bunch of those straight line segments and apply a geodetic reference, like a WGS 84 or a GRS, like you suppose, whatever the case may be.
We don't apply that to leveling. What we're talking about.
So you don't apply that to leveling. So if it's straight and you have your datum essentially, right? You have your entire whatever you like. Let's say 100, not 100 square miles. Let's say 10 square miles, right? Between each of these network points that you already shot a level to, right? You're basically trying to keep it at 100 feet elevation or whatever the elevation you want. What the Glober will say is like, oh yeah,
we're not trying to keep anything at any elevation. We're just trying to measure what the elevations are. We're not trying to keep anything. We're trying to start with a reference.
You're establishing a horizontal with your auto level though.
No, it's not
Equal
establishing.
elevation from the observer to the pole.
Yes.
Well, okay, I mean that's a
And-
level line.
Yeah.
That's a
level line.
horizontal line. Yeah. Equal elevation.
Yeah. And the thing is,
It's not
if you
equal elevation.
if you try to
Huh?
assume curvature between
It's just
100 meters
straight
apart,
versus
right? It's going to be negligible. Right?
But it accumulates, right? But if you take that, if you don't account for that error, even though it's small and negligible, it will start to accumulate and build up into a big,
Right.
into something that is not negligible, into something that is significant over a long enough distance.
What's
But
the
do you-
deviation over 1600 meters?
Yeah.
1600, let's see, 1600 meters. It's going to be very small. I mean, it's going to be in the matter of millimeters
what?
or a centimeter.
A meter?
No, it'll be
Half a
1600
meter?
meters. If you go measure, if you're talking about the difference of curve to a flat measurement in 1600 meters, it's going to be, I don't know. It's going to be measured in millimeters or centimeters. I don't have.
You're breaking up, can't you?
You're going kind of quiet, Phantom. Going away from your mic.
Okay.
Oh yeah, there you go.
Yeah, the 1600 meters. I don't know. I don't have a curve correction calculator in front of me, but it's going to be.
Oh, I thought you'd know it off by heart. I mean, I would if I was doing the job.
Yeah,
I'd know what it would be.
I don't know
over
exactly.
1600 meters. I mean, I would have thought.
I don't work in meters.
that
I'm
would
in the
just be
United
in-
States. First of all, I can tell you in 700 feet.
We'll do it in feet then.
100th. We'll go 700 feet. It's 100th. I know that by heart. I don't work in
100
meters.
what?
100th of an inch.
100th of
Of it-
100th of a foot.
100th
of
an
a
inch
Of a
over
foot?
700.
Engineer scale, 100th of a foot, which is equivalent to 3 millimeters or 1/8 of an inch.
Okay,
So
an eighth
over
of an inch.
700 feet. So over 700 feet, you've got an eighth of an inch
Curvature.
Of curvature.
difference.
Yes.
So,
So if you-
700 feet, so that would be 7.5. What's
And it
that?
goes-
In
the error is-
5,000.
The error is going to go the same direction
7,
every time, so it's just going to compound and accumulate and build up the further you go.
Yeah. So what would it be over a mile?
A mile would be like what? Over an inch?
Take a mile divided by 700.
Right. And it's an eighth of an inch.
Times 7.
So it's almost an inch.
About an inch. Yeah.
Right. Okay.
An
So
Mile is very
an inch
short.
drop
Mile-
over a mile.
You guys think
over a
miles
mile?
is
So-
long? Mile is
well, hold on.
short.
Wait.
It's a super
Hear me
short
out, bro.
distance,
Guess what the globe claim is? Between that mile, it's supposed to drop 8 inches.
Yeah, if you're staying in one position, I'm taking a measurement 700 feet at a time and moving ahead. If I was taking one observation that was a mile long, it would be 8 inches. I'm not taking an observation that's a mile long. I'm taking. We just said 700 foot incremental observations.
Uh huh. And if you
said
do that,
130 meters, that's not 700 feet.
but
No,
the
700
point is, if you do it straight line segment wise, right? Like if you go from one point to another point, you're even what you just said, the deviation is so minute, so negligible, right? It's only an eighth of an inch for 700 feet.
A 700 feet measurement.
So
yeah.
700 feet
Horizontal
times what?
distance measurement.
7, almost 8. So you're talking about over a mile. It would be only like an inch of deviation.
With that method of measuring. And then you're comparing that to taking one measurement that's 5,000 feet long. That's two different things we're talking about. So if I took one measurement that was 5,000 feet long and I didn't leapfrog every 700 feet, then it would be 66 or whatever it is.
So you're talking about a
0.66, 8 inches.
700 feet measurement with an auto level now? Or
No, I'm talking about.
130
We'll talk.
meters.
We'll talk with it. You can. There
Right,
is
but-
auto levels that can go that far. We'll talk with the total station. The same principle if we're using a total station for traverse, and we're just paying attention to the elevations. We don't care about curvature. Or I'm sorry, we
and
don't
you've
care
got
about
less than an
horizontal.
We don't
eighth of
care
an
about
inch
curvature.
accuracy?
I'm
That's
sorry.
right.
We don't care about horizontal measurements. We care about. We're just talking about the elevation change that we're getting right now. That's what we're talking about. So you can go even longer than 700 feet. That's just a number I pulled out because that's an optimal.
That's a standard,
turn
right?
length.
I got you.
That's close to an optimal turn length for a traverse. So it's the same thing I was just describing for levels. We do the same thing with a total station or what used to be called a theodolite. And you're leapfrogging ahead. But yeah, so the 700 foot measurement, the curvature error is small, and then you take those small segmented measurements and spread them out over that mile, yeah, the curvature error is not the same as if I just shot one direct measurement for a mile.
Okay, all right. Well, just think about what you just said right there.
I did.
Okay.
This is why
It's
you
not
guys
the
need
same.
diagrams. You guys,
No,
this
no.
is why we need to have diagrams to show you guys how this works mathematically, because this is not easy to like get your head wrapped around 3D spatial geometry inside your head and understand how.
No,
this
dude, I
different
understand.
works.
You don't have to say I don't understand. I get it.
I don't think you do.
Okay, do you understand what the globe paradigm is, right? The claimed curvature of the globe, 3959 radius.
8 inches per mile. Yes.
8 inches per mile squared until you get up to like 1100, 1200 miles. Then you have to do a different formula, yada yada.
I just said it would be about 800ths, which is about 1 inch in a mile. But what you're not
Guess what?
understanding is we're talking about two different measurement methods. I'm not shooting one mile observation. I'm shooting multiple 700-foot observations.
But the curvature is what's in question, my dude. And what you just described states that the curvature is off by 7 inches.
No, it's not. It doesn't state that the curvature is off by 7 inches because I'm not taking.
If you added up all those little errors that you just said, over a mile.
No, it's because what you're not paying attention to in the curvature formula is it's squared, so it's exponential and it just increases the further out you go. Okay, so what I gave you was the error in 700 feet. It doesn't just accumulate 700 feet at a time. So
that's exactly what you just said.
Measurements.
So what is it? A half a mile?
No. When you're comparing the 8 inches per mile square formula, that's not how the formula works. It's not measured 700 feet at a time. That formula has a square to it. So it's exponential. It's parabolic.
Over a mile, yeah.
And it just keeps going. It's not over a mile. It's based on a mile. The formula is based on a mile, but it just keeps, the error just keeps getting bigger and bigger exponentially. It's not an even amount every mile. It grows every mile. So it's also growing every foot, every 100 feet, every 500 feet. The error is not equal. The error is not equally distributed, or sorry, the curvature difference, whatever falling away error, whatever you want to call it, it's not equally distributed. It's constantly growing, right? So that's how that formula works. So what I gave you is what that is in 700 feet, and then we take these short observations and piece it together. At the end of that, yeah, that's what the error.
That formula. Sorry, go ahead. My bad.
You're conflating two different types of measurements. You're conflating a 1 mile measurement, direct measurement across 1 mile versus multiple 700-foot measurements that add up to a mile. And you're saying,
okay.
Why doesn't the error match up when you're saying if it's 100th per every 700 feet?
Exactly. Yeah.
Because it's exponential. We're not taking one 5,280-foot measurement for a mile. We're taking multiple 700-foot measurements. So
right.
We don't have time for that. The exponential measure, the formula being applied exponentially doesn't have a chance to grow to 8 inches when we're not taking that one 500-foot measurement. We're moving the instrument ahead, so it's falling away. If I had a diagram, I could show you how this works. But every time we're starting over again with that formula. We're not taking it from one place and trying to stretch that measurement 5,000 miles. We're moving the instrument ahead 700 feet, moving it again. So each time we're starting over with that correction formula.
But remember what you said, right? If you do not take into effect the curvature. Hold on, bro. I didn't even get to finish. Okay, but I'm going by what you just said, all right? Earlier you said that if you have this error correction, this curvature and refraction correction that needs to be made, it's negligible after 700 feet, right? But like you said, over a longer distance, that will be exponential, correct?
Right.
Okay. So based off of each line segment of 700 feet, you only get 1/8 of an inch in terms of an error, right? All right, so let's say I don't correct for it.
Longer measurements than that. We're just going off an example.
But let's say I don't use the curvature refraction correction. Let's just say I don't use it, right? And I go to the next segment, another 700 feet.
Right.
And then you get that error again of 1/8 of an inch. Okay, and I go another 700 feet.
The same way, and it keeps adding up, and it goes in the same direction. The error goes in the same direction.
Yeah, and it adds up to an inch.
Right. That's 1 mile.
Okay,
That's a
that's
very
not
short survey. So if
that doesn't comport with the globe model. You just
Yes, it
proved
does.
flat Earth.
No, I just explained to you why it's two. You're conflating the curve formula with a totally which is one observation for 5,000 feet in distance with a totally different set of observations 700 feet at a time, where I'm moving ahead and starting with my instrument now looking at a different plane. It's not shooting out over the same level plane. If I stayed at the starting point, that level plane doesn't change and it falls away 8 inches. But if I move my instrument ahead on the globe, it's now I'm tilted in relation to my first setup, and my level plane that I'm sighting is now angled down more, so there's less error.
But in
So
reality, that's not how it is. You just said it.
No,
you
it's
just
not.
said 700 feet, an eighth of an inch of an error correction is needed. But if I don't correct for it every 700 feet and it accumulates, then it accumulates up to about an inch.
I'm not going to keep saying it. You're conflating the two different. You're conflating a 5,000 foot measurement from one point with multiple 700 foot measurements combined together, and it's not the same thing. It's an exponential formula. You need a diagram, but I'm trying to simplify the explanation. Is every time I move the instrument. So if you're looking at it from the side view, just pretend for the sake of argument that the instrument is set up and you're sighting a straight, whatever you guys want to call it, a horizontal line that goes straight out into space, has no
Right.
curve to it. And
Yep.
then beneath that instrument, just picture this, the curve is falling away from you. Okay, so if I take that along that horizontal line, 5,280 feet or a mile, that curve, theoretically, we're saying is dipping down in relation to that level line that's going out into space, 8 inches. Okay. So what I'm telling you is, we're talking about 700 foot incremental measurements now. So every time I move the instrument ahead, that level line is now on the globe. It's on the curve, right? We'll just say theoretically, hypothetically, the globe exists. That level line that points out into space is not on the same vector anymore. It's pointing down at
the horizontal
at an angle, and it
but
keeps
the horizontal
pointing down
benchmark
more.
is
That's why
the horizontal
error
benchmark is consistent, isn't it?
No.
Despite what the surface is doing.
Right. That's the point, bro. Like
I tried to describe this to you. You need a diagram. You're trying to conflate.
Yeah, but if you did 8
different things
transits,
that don't
an
go
eighth of an
together.
inch, and then you looped it back, then you're saying
every
that,
700,
your pluses and minuses would add up
about
to
an inch. Right.
No, if all of our a 1 mile loop.
Which one do you use then? Do you use the inch or the 8-inch one when you're surveying properties that are it's valuable land you're having to assess?
Well, no, I mean, when we work in tenths and hundredths, but we use we use various units because some formulas are based on, like, that formula is in inches. It doesn't matter. We know how to translate between
What's
the
a
different
half a
units.
mile?
Sometimes we
Half
use
a mile
meters.
is what? What's a half a mile?
Half mile in what? In feet?
Yeah, what's the drop over half a mile then?
Exponentially, I have to get the calculator. I don't have all these memorized, dude.
2,600 feet, like what? Times 4,
you can do it in
half
your
mile.
head, can't you?
Yeah, it's like 4.
Half a mile with your 8
exponents
inches
in my
per
head.
mile.
4/8 of an inch. 4/8 of an inch. 5/8 of an inch. Just about. Right. Simple math.
Yeah, I don't know. It's
2 inches. It'll be 2 inches.
Okay, so so I don't understand what the point you're making, though.
The point is, it doesn't comport with the globe paradigm that's been assumed.
I just explained. I'm done. I got to move on. I got to go to bed. I explained it to you guys. You guys need diagrams to show how this different stuff works. And maybe like Big Tech was saying.
Hey, listen, I appreciate the back and forth, bro.
Rederive the geodetic coordinates on this network of control points that we have in these models that are all somehow hoaxes, and they somehow all fit together.
Pre-assumptions. We never said hoax. We said a pre-assumption. Don't put words in our mouth.
It would have to be a hoax. It would have to be a pre-assumption.
That's only adding up numbers, man. It's only adding up numbers.
It would
8 numbers or 1 number. That's all.
It would have to be. Look, it would have to be a globe model that was built to deceive everybody. That's somehow
exactly
got
right.
math on it, and this whole
yeah, but you're the guy. You're the guy telling us the
all
figures.
these measurements
we
that
add
we
up
take
figures.
are all hoaxes based on hoax models that are but you can run the
Dude, this
math
is
on
not
these
a
models
valid
yourself.
argument. You're just spilling your emotions. This is not a valid argument. The
I'm not
argument,
spilling
I
emotions.
guess you're going now, so you don't
Talking
want
about
to
how
debate
ridiculous
anymore,
it is.
but it's quite clear. We've been very consistent with what we've been saying. Your geodetic, all of your surveying data is flat data. You can't get away
It's
from
not.
that, dude.
It's not flat
I'm
data.
sorry. It's been
When you
proven,
take
we
when
can
you
only
take
drive this
celestial
home so much.
observations and you derive latitude and longitude spherical coordinates, that's not flat
All
data.
that's
That's
all
not
have to do with the stars, bro.
You're just
That's
not there yet, bro. You're just not there.
doesn't
You
but
matter.
don't
it's
know
okay.
that the
It fits
longitude and
measurements on the
latitude
ground though.
coordinates.
We're
Yeah,
not.
but
We're
the
not.
longitude and
I
latitude
just,
coordinates are
It's
spherical
it's
coordinate
based off of
systems,
the.
dude.
It's based off the
I just
stars,
think
but
you're
it's
not a
measured the points
surveyor.
on the
That's the
ground.
bottom line.
Well, real quick,
Yeah,
Phantom. I know you have to go. I just want to say thank you for the back and forth. I would like to continue this
Trying to help you guys.
conversation in the future.
I'm trying
Maybe
to
I
help
can
you
give
guys
you some
stop
more
wasting
data.
time and then spend some time on some better,
shut up,
truer
Phantom.
subjects. All right, take it easy, y'all.
Stop interrupting people mid-sentence, mate.
Roots, he didn't. Roots is like, I'm done. Tired of this.
I tried to stay out of it as much as I could because I feel like he was dishonest, and you handled it pretty well, but I would have lost my temper with him
I don't
earlier.
think he's dishonest. I just think he has a bias, just like all people have a bias. But the thing that's in question is the assumed globe, which has specific dimensions, and these dimensions are they're never actually verified. They're reified. That's the point.
It's a hard concept to get people to buy into or to even comprehend. Like I've been following flat earthers for a while, and I'm just really just starting to get what you guys are even saying. It's hard to wrap your mind around because it really, like, he's saying that it's, he refers to it as a deception, but you have to give him his some leeway, I guess. He would assume that it's that, but you're saying that it's not a deception. It's actually just sort of like an assumption. So they were assuming and
Well, no. It
believing
is
that
a
it was a
deception.
globe.
Overall, it is a deception if it's not true, because of all the different avenues in all
Right.
different
Yeah.
types of
Well, I agree.
categories that reify the globe for the philosophical bias in the first place. That we must be on a ball. It has to be curved. Everything that doesn't match that,
Right.
we have to correct for.
So you're
And
saying
this
it's a
is what we're
philosophical
saying.
assumption that they've
Yes.
constantly been making these false adjustments to match their measurements to the thing.
The idealized sphere or spheroid. The idealized spheroid, which is always conflated with latitude and longitude, a spherical coordinate system, the idealized celestial sphere. But in reality, when you go and make actual measurements, like in terms of GP to start, like in reference to the stars, so you're taking like a zenith, right? You go out a certain distance, then you go to another zenith, you basically get an elevation angle, right? And you find out that, hey, this actually doesn't match our idealized sphere that we were trying to create. So what do? We have to make these error correction tables and site reduction tables and all these other different corrective tables or corrections, because what we're trying to idealize is not in comport with reality. And that is our point. That is our position, is that reality is reality.
Right.
It doesn't need to comport with the idealized sphere. And that's the philosophical bias. That's it.
Yeah,
So he
we get so into the dirt, we get so into the mud of the conversation that this was stated at the very beginning. All surveying and GPS references a flat Earth first. You need a tangent plane, and all measurements are in respect to that flat horizontal reference. So you're mapping the Earth as flat, but assuming it as a sphere, and giving
making corrections to it, right?
But the surface
Yeah.
isn't horizontal. But the surface isn't horizontal.
No, every measurement is taken in respect to a horizontal reference.
Is horizontal, but the surface isn't.
References
but
to
the
horizontal
surface is
intersections
parallel
at the point.
But the surface is parallel to that horizontal reference. Yes, it is. It has to be.
The flat Earth has to be measured by the same system as the curved globe one, and it is in reference to a horizontal. And if you measure elevation changes, then you're not measuring, you're not establishing the surface to be horizontal, are you?
But we're not measuring elevation changes because
of course you are.
Not
Why
in
are you not?
yeah,
Where
I'm trying
are
to
you
tell
not?
you. Yeah, I'm trying to tell you that when you do navigation, you can create something called a circle of equal elevation. That's hundreds of miles of flat Earth, horizontal reference that's parallel to the Earth. When you go to each one of those points, you will find that your horizontal reference is parallel to the Earth. So you're literally establishing hundreds of miles of flatness with a circle of equal elevation. Celestial navigation.
And
Well,
then you put it to a globe, right? You put it on top of a globe. You're like,
just
ah,
drawing a
fuck, this doesn't
circle
work.
from an
This is
angle.
there's spherical excess
You're
here.
just
We need to
drawing
correct
an
this.
angle from a circle. A circle from an angle. That's all you're drawing.
Yeah, you're getting horizontal points all over that place, but you're not establishing that all those
You're only measuring an
horizontal.
angle.
You're
You're
not.
not measuring a
There's no way to
horizontal.
establish that all of those horizontal lines that you draw to those plumb verticals are parallel.
Well, on a globe, you would have decrease in elevation, from your observer's position outwards at a certain rate. So all you have to do is make these multiple points and then go over to these areas, and you can literally establish that it's horizontal, it's locally flat for me, you, on all three of these points. On all of these points, it's always horizontal, flat. So the only direct evidence we have is of a non-curving surface. Yeah.
You do have
The first
elevation
sentence is wrong.
changes
You wouldn't
on
have
the Earth,
you wouldn't have
flat
any
or
elevation
curved.
change. You wouldn't. The elevation would be the same on the sphere.
I think it's important to point out before you guys continue on the science that this man, he was not being, whether I agree with him or not, and that has nothing with the point made that I'm making. This man came in and he was not being disingenuous. He was actually attempting to talk with you guys about the points made. But you gotta realize that these pretty normal men that have learned this methodology, they imagine whoever goes in opposition to the consensus as being pretty wild or out there, or stupid, or just confused, and every other terminology that you guys have to them. So he was actually being pretty patient, and I would say that he seemed to get surprised when you, Beasticles, when you were talking with him, that you could give him the information that he was about to say. He got silenced some places. So I think you got him to think about some things.
That's all I wanted. Dude, I'm telling you, most surveyors don't even think about the shape of the ground until someone mentions it, and they're like, holy shit, it is flat. I'm telling you,
I'd like to have. Do you guys know any surveyors that are flat earthers that you could have come and talk to him? Have a surveyor.
Yeah.
Yeah, if we set that up, I think that'd be cool.
Sorry, just took a fat hit. Yeah, freaking Elijah Seraphim and Rakia Life. Those are the two I know.
I could get him.
I'm
back
sure there's
in here
more.
sometime.
Apocryphon too, I think.
I don't think he was being completely disingenuous, but he was purposely not understanding what we were trying to tell him, and he's more than intelligent enough to understand it. Because if he admits, because it's a very important point. If he admits what we're telling him is true, which is all of your data is flat Earth data, which is converted using this process, the spherical coordinate system, then what he's admitting is that all of the original data for his globe is flat Earth data, and he's smart enough to know that. So that's more than that. He's being disingenuous.
It's more than that. He thinks that if he starts to use the terminology and agree with you guys, he thinks that he will be abetting in facilitating a psychosis.
No,
that's not my problem. I don't give a shit about that. That's not my problem. He can keep that problem to himself.
I get that.
He just has to deny his system. That's the problem he's in. He's got to deny what he's actually doing.
Right.
He's establishing a horizontal reference, and he's having to deny that, and that's the crux, the difficult place he finds himself in.
Yes, but you see,
he knows he's establishing a horizontal, and he knows that when he's talking about it, he has to deny that he's doing them.
Right.
Well, you guys are. I think you have to present some hard evidence to him that they fudged the numbers on the geodetic survey.
No, it's not about fudging the numbers. It's not about
Well,
that,
no,
bro.
We
well, I
went
think
through
it is
the
because you said
process of
before that
being done.
when they did the survey to set up the coordinate system, you're saying that sometimes the triangles were either 180 or less, and in the survey it would have to be
In,
always more.
in reference to whatever geoid you're applying it to.
I'm trying to
Yeah.
locate Witsit right now. Like, what coordinate system should I use?
Doesn't even make sense.
Flat Earth Dave's app. I heard that
Oh,
has
that's
the
actually
locator built into it.
that's good advice.
Yeah. It'll tell you right where Witsit is. But yeah.
See, this is about reality versus math and models. And I think a lot of globers believe that a model is evidence in reality. And I think what we're trying to point out to you here is your model can be wrong if you make one pre-assumption. If you make a pre-assumption, then the whole model can be wrong. And this is what we're trying to point out here, that everything in the natural world is telling us that we're dealing with a flat horizontal plane when it comes to water. And evidently, water is always seeking its level. Level is always synonymous with a level object will always have a flat surface. So I think definitionally, I think logically, I think in the natural world, this is what we're observing. And you've just got to be honest that the globe is a belief. You know, and he started his whole rant with, "Oh, you flat earthers, you're into belief," and I'm like, dude, you're literally doing what you said earlier, and the flat earthers are trying to school you how to go back to logic and discernment. So I find him a little bit what's the word? He's a little bit arrogant.
No, it's. I mean,
no, I don't think it's
from my
arrogance.
perspective, it's actually you just are projecting that onto him because everything that you just said is sort of like assuming that everything that we see is that it looks level and not curved. But it's like I could point to a bunch of things that to me look like a curve, and
Like
then
what?
you'd say, "Ah, no, that you have an explanation for that."
Like what though? Like what can you point?
Yeah,
to?
like what? Give an example.
I mean, just like the way that the horizon acts. Like for me, when I see the sun go down, I mean, this is so basic, and I know your answer, so we don't have to go all through it. But like, it looks like the sun's going in the water, but then the explanation to me is like, oh, it's actually just going behind something. That makes more sense. I see things go behind things all the time. I don't think the sun's actually going in the water, but it looks like it is.
What does that have to do with curvature, though?
Well, so if you tell me that, so a curve makes sense in that situation, right? So when I look out and so that's what makes sense. So when I see something that doesn't make any sense and then the explanation makes it make sense, that equals now it looks like, okay, it looks like I'm looking at a curve situation. It's going over the curve. That makes sense. It's going behind something. Somehow it's going behind the water. In order for it to do that, it would have to be curved.
Well, no, see, that's an assumption that has to be curved, but you're not actually seeing curvature. So do you have another example?
Do you think you could be misinterpreting perspective and maybe you don't fully understand what's possible on a flat surface with an atmosphere?
Yeah,
that seems more likely.
Well, I don't think it seems more likely that there's some misunderstanding of perspective. Like I'm pretty familiar with perspective. I see different things in different perspective all the time. I'm familiar with railroad tracks. I'm familiar with a line of trees on the side of the road. I see things go far away from me and get really small and tiny into the distance all the time. And that's not what the sun does. It does something else. So it makes more, but I also see things go behind.
I said with an atmosphere. I said with an atmosphere. Are you aware of all of the bottom-up disappearance effects that can happen due to the atmosphere and weather?
No.
But isn't that what this guy was here for? He was talking about measurements, not observations.
But see,
right.
You're talking
but
about
he's brought up the horizon.
Well, no,
but the horizon. What is the horizon? The horizon is Yeah, but he's brought up the horizon, and the horizon is a completely unique position based on an observer's limitation of view and the atmosphere and the weather conditions. There is no geometric horizon that you can find. So the horizon is purely a flat Earth argument. There is no geometric horizon, and we can prove that. We've debunked the geometric horizon.
Right.
No, but it's so funny. But the way you'll debunk it is by saying we're seeing beyond things, and then when we say, yeah, but that's because of atmospheric conditions and refraction, you'll say, oh, very convenient. But when I say look at how this thing looks like it's going behind something, you say, oh, that's because of atmospheric conditions.
Yeah, because you're not able to understand that there's multiple. Well, I don't mean to be rude to you, but a lot of globers don't understand that there's multiple effects going on at once. But the question I want to ask you is, what is the horizon? What is the horizon? Can you define it?
Yeah, it's the line where the ground and the sky seem to meet.
And is it a physical location or is it just an apparent location?
It's apparent.
Okay, so we do not have a physical horizon then, correct?
Well, since we're describing something that relates to vision, we're talking about something that
Just
we
the horizon,
see the
bro.
horizon. Yeah.
Is the horizon a physical apparition or just an apparition?
Well, technically it's physical because light is physical. So we're seeing something with light. Light is a physical phenomenon. So it's a physical.
No, we're not asking that. We're asking, is the horizon geometric or apparent?
Right.
Well, it's both.
Well, see, that's...
Nope. This is where you guys just crumble. You will just crumble now because it can't be both. No. Because if it's a physical location, then that means there should be an actual place where the Earth is now curving and things behind that are physically blocked by Earth curve.
Right.
Yeah, that's what is going on.
Okay, so what happens when we see further?
Atmospheric lensing, yeah, atmospheric
for refraction. And
yeah,
then you have
exactly.
a slider bar. Basically, it's okay. We're assuming ball, so there must be this much refraction to make it look flat.
But it doesn't look flat.
Right.
Dude, this is why I said you guys crumble. When we ask you to define the horizon, you crumble because you can't have it both ways.
I didn't crumble.
And
you can't
there is physical obstruction. Either
How
the
can something
horizon is a physical obstruction, or it is completely a unique position based on depth perception,
the observer,
atmospheric conditions, and the thickness of the atmosphere over distance. Simple.
It can't be physical and not physical. Like it can't be a geometric position or an apparent. It can't be both. It's either one or the other. It's either apparent or it's a geometric position. Like
I know that you feel like this is like a big point, but I also know that you get
massive
it.
one.
Yeah, dude. I mean, it's a paradoxical, and like, how can you say that it is
it's
physical
literally just
and not physical?
What it literally is just a word concept fallacy that you're drawing.
Nope. See, you guys crumble. You can't define the horizon.
I didn't crumble. No, you can keep claiming that. You're claiming victory by completing a word concept fallacy.
No. It's very simple, bro. The reason why this is an important question is because this is what's in contention, which is Earth curvature, right? Why do boats disappear over the horizon? Well, it's blocked by geometric Earth curve. Yeah. Okay, let's go test that claim. How far is this geometric Earth curve from an observer standing at 6 feet, for example? 3 miles away, according to the idealized globe that is in contention, right? All right, now we see further than what the geometric globe allows you to see.
Yeah.
Because it's supposed to be physically blocked, correct? You can't get over that. It's physically blocked. What would you say then? Would you say that the ball is in question now? Like, maybe we're on a giant ball, or maybe that it's flat. Either way, the pre-assumed dimensions of Earth are now in question. Would you not agree with that, at least?
Well, yeah, I can agree with that at least, but like, look.
At least, just for now.
Now, let me give the reply, though. It's like this. Here's what you're doing an equivalent of this, I think. So I'm in my hallway, and my bedroom is around the corner because my hallway makes a 90-degree turn. And I'm looking down my hallway. But at the end of my hallway, there's a mirror at 45 degrees. So I'm looking at the mirror. Light is bouncing off that mirror, hitting my eyes, and I'm actually seeing into my room. So I see in my room, even though my room is out of view. And that's because light is bending down the hallway.
Physical mirror, bro. You're talking about a physical mirror.
So exactly. But so now here's the question to you. When I look down the hallway, what am I seeing? Am I seeing my room or am I not seeing my room?
Yeah, but you're invoking a medium, which is the mirror, that basically light's reflecting off of.
Exactly. But
Okay,
am I seeing the
we're
room
not
or
talking
not?
about that. We're talking about the horizon,
but,
bro.
But for this point though, am I seeing my room or not?
Yeah, you're seeing your room. You're seeing a
But my room
reflection
is
of your
out
room.
of view. How could I? Oh, am I seeing my room or not?
Yeah, you're using a mirror, basically
So
something to reflect
so the
the
full
light.
answer is that I'm seeing my room and I'm not seeing my room. I'm actually just seeing my hallway, but I'm also seeing my room because the light from my room is bouncing into the hallway.
Okay, so
So I'm
what you're
seeing my
saying is
room and I'm
refraction
only
is the
seeing the
reason why you're
hallway.
able to see too far. Okay, we went back
Exactly.
to the
So
refraction thing.
so the
it's
curve is there.
unfalsifiable.
I can't see over the so I'm seeing over into a place that's out of view.
Yeah, so you're basically saying, oh well, it's a ball, so it must be refraction.
No, he's like saying that the mirrors are like everywhere. Like everywhere he goes, there are mirror. Like that's his claim actually.
Yeah.
No,
I mean,
not exactly.
that's-
What I'm
that's
saying
what-
is that, well, like
This
a mirror,
specific claim.
in the same way that the mirror is allowing the light to change directions, also the atmosphere allows the light to change reflections. We call that refraction instead of reflection. It's just a similar phenomenon. The light is changing directions.
You need two mediums for that.
So refraction
Snell's
for
law.
thee, but not for me.
No, I'm saying that you're doing it too. So when I say, why does the horizon look like that? You go, oh, atmospheric conditions cause things to disappear from the bottom up. When I say, why does the horizon look that? You guys say that to me. I say, well, the horizon's there. It's going behind a curve.
We don't say the
Atmosphere
horizon's
is
physical,
allowing
bro.
the light to bend over.
We don't claim that there's a physical geometric horizon.
All right,
That is
I know
what the
you
globe,
deny that. You deny that there's a physical horizon. You deny
Yeah.
that there's something that is going behind.
and you
And you have to
reify it with
prove
refraction.
The horizon,
Yeah.
the
Yeah, it
horizon
doesn't
is
exist.
not geometric. Is that what's being established?
Right. So refraction doesn't exist when I need it, but it does exist when you
No
need
one said refraction doesn't exist.
it.
No
I
one
thought
said
that guy
that.
just said it. Oh, my bad. I misheard then.
Oh, I don't know what Elder Bear said, but I didn't say refraction doesn't exist. But what I am saying is the amount of refraction needed for some of these long distance observations would basically turn the R value, the radius value, like 15x, 27x, like Witsit was saying.
I haven't seen any evidence of that. All the claims that I've seen brought forward of like, oh, we see way too far here. When I've examined those, they all seem like totally within the bounds of expectation.
But like, do you understand that the horizon changes dynamically every second of the day? Like, let's say, have you ever looked at I think it's Skunk Bay? You ever see the Skunk Bay GIF?
Oh yeah, totally. Because the atmospheric refraction index is changing depending on the atmospheric conditions.
So the horizon changes, correct? It's apparent.
Right, as
depending
if
on the
in
observer and the
analogy,
atmospheric effects
the
and
analogy,
everything.
it's not a perfect comparison, but the analogy would be as if the mirror was, moving a little bit by a few degrees at the end of my hallway. I would see different parts of my room. Does that make sense? So like if as the atmosphere gets
So now
goes
long
through
distance
different-
observations are completely nope, it's refraction. Every single long distance observation you ever do is just saying, oh, it's refracted up or refracted down.
Yeah, that's what he's saying. He's saying
You're basically
everything
saying it's
beyond.
unfalsifiable. Like, how would you try to challenge the globe radius then? Like, if you were in our position and you wanted to challenge the geometric claim that is 3959 radius of Earth, okay, has specific dimensions, you want to challenge that claim. Now, you can't use long distance observations now, which basically allow you to go to sea level. And why do you go to sea level? Well, because it's level, right? Zero elevation. But now you're saying we can't use that because every single long distance observation is affected by refraction, and the refraction is basically saying that's why it looks flat.
Everything's a mirage beyond about 5
Which means,
miles. That's what he's saying.
hold on a second, Roots, hold on. Which means we're down to now tangibility. We're going to knock out the long distance stuff. We know refraction is making things be in their not actual position. So we're going to get away from the optical and we're going to go to tangible stuff. Tangibly, level measures horizontal. Even the globe admits it. You have to go out so far before there would be any measurable difference. So here we are with the measurement now of level measuring horizontal.
level measuring horizontal.
That's what we're left with.
Horizontal is a direction.
That's all you're left with.
relationship.
We threw out the optical stuff. Now we're
Right.
just left with level measuring horizontal tangibly. Even the globe admits you'd have to go out hundreds of yards before there would be any measurable difference.
Yeah,
Right.
Exactly. So the problem is that what you have as the basis from what I keep hearing from you is that the Earth measures flat, but then when we
Yes.
analyze it, we go, but the problem is we have apparent phenomenon that are problems. Like sometimes you can
No.
see across the base, sometimes you can't because we have atmospheric refraction. You
We
agree
know
that
we
it
threw out the
happens.
optical
We
stuff.
threw it out.
We
Yeah.
can't
Exactly.
we
So
can't,
without that, what do we
threw out
have?
the optical stuff. We have hold on, man. We threw out
So
the optical stuff. We are the
Good.
only one left with a measurement now of level measuring horizontal. You have no measurement.
What measurement do you have that's level is horizontal? Horizontal is a direction.
How about fucking
Horizontal is
line
a
segments of 10 miles, like between 10 miles, like that we were discussing?
How did you measure those optically?
no. You forget 10 miles, dude. 10 feet. We have a 10 feet. Even on the globe, level is undistinguishable from horizontal.
10 feet is undistinguishable from horizontal.
Over
What are
10
we talking
feet,
about?
level and horizontal are indistinguishable. Yeah, there is an immeasurable. You cannot measure a difference.
Yes.
And that is why.
That is why I would say
Yeah,
it's because level is horizontal. You would say we don't
no,
have a tool good enough to measure it.
right. So what would be the angular change over 10 feet if we were on a sphere with that radius value?
I don't care. I don't care. The point is, I'm sitting here with a measurement of level measuring horizontal, and you don't have a measurement.
Well, the
You don't
problem
have
is
a
you don't
measurement of curve.
No, but what you don't have is a measurement fine enough to say that you've ruled out the curve.
No, you don't have you have a begging the question fallacy saying there is a curve there.
Well, I have a million other reasons to say that it is curved beyond
I have an
optical.
actual measurement. I have an
No,
actual measurement.
but you don't have
nothing.
you don't have a sufficient measurement. It's not valid.
What?
My measurement is absolutely valid. You
No,
don't
it's
have
not
any
because it's not.
I have
because
an
it's-
actual measurement.
But it's
I
not
have an
accurate
actual
enough to be able to
measurement.
say
You
that
don't.
it's ruled anything out.
That's your
Huh.
baseless assertion fallacy. We
It's
know.
when?
You're just
Why?
saying it's curving.
No,
You're
because
just
I've
saying
asked
it's
you
curving.
how much
I
curve
have an
would
actual measurement.
sir, how much what's the angle of change over 10 feet if the R value was what we say it is? You have to know what that is and then
It would
say
be
I've
very
ruled
small.
out.
I know it would be very
Right.
small. You guys are
It'd be
saying it's there. We can't measure it.
0.0000000 something angle.
I know it's
Right.
very small. You guys are saying it's there. You're saying,
So-
"Hey, trust me, it's there. We can't measure it, but it is there. You need to
And
go
you're saying,
farther
trust me,
out."
bro, it's
Hold
not
on, man.
there.
Can you
Yeah, I
stop
mean,
for a
it's
second
a-
while I
Yeah,
talk?
don't interrupt him. Yeah,
It's-
go ahead,
it's-
Jeremy.
It's the law of imperceptibility, isn't it? Too close, you can't see it. Too far away, you can't see it.
I don't know.
So what
I
I'm
don't
saying,
know why
you
you
can't
thought
claim
that's a
that
good
you've
time to talk.
measured
Now
that.
he's gonna go again. Jesus Christ.
Can you guys let Jeremy finish, please?
Go
Big
ahead,
Tech.
Jeremy.
We are sitting here with a measurement of level measuring horizontal. We have an actual measurement. You are saying, hey, there's a curve there. You just can't measure it. It's so small. It's 0.00000. I don't care about that. That's your in your mind because you can't measure it. You're just saying it's there. We have the actual measurement. You don't have any measurements.
Is it my turn now? I think it sounds like I don't want to interrupt you again. You're saying we have the measurement. I'm saying no, you don't.
Where's your measurement of curvature? Sorry, go ahead, Jeremy.
You're just saying
Sorry,
that
bro.
we do. You're just saying we don't have a measurement. We do have a measurement. Level measures horizontal tangibly over 10 feet. Even the globe admits you can't measure any curve there.
No, we don't admit that you can't measure any curve there.
So you're saying you can measure the curve. What you can measure level curving over 10 feet. You can measure a difference of level and horizontal over 10 feet. You're saying that?
I'm saying
Bullshit.
no. I'm saying that you have not measured to the degree that that you can now claim we have measured this sufficiently to establish that it's level over 10 feet.
Yeah, I know. Because you're saying you're just
So you don't have a
saying there's
sufficient
curve
measurement
there.
to say we have a measurement.
I thought you were
have
done,
like
bro.
an
My bad.
imprecise measurement. You can't stand on an imprecise measurement and say, "Ha, we have something."
What imprecise measurement are
you
you
good?
talking about? Go ahead, Jeremy. Fuck, sorry.
You're just saying that there is a curve there. You measure, you get a level and a horizontal. You put them up against each other over 10 feet. Even the globe admits the curve would be so small that it would be immeasurable at that distance. Now, that being said, that's all in your head because you're just saying the curves there. You're just saying levels curving. When it comes down to actually having a measurement of that, you don't have it because all you have is the optical stuff that we threw away, and we have a tangible measurement of not being able to measure a difference between level and horizontal. So we have the measurement. That is an actual measurement of level being horizontal. Just because you're saying that, hey, trust me, bro, there's a curve there, you just can't measure it because your tool's not good enough. I don't care. Then measure it and show me. You don't have a measurement. I do have a measurement.
But do you have a precise measurement?
The best tools on earth can't measure a difference between level and horizontal. Yes, it's a very good measurement.
Let me say it this way. If the Earth was curved with the radius value that we presuppose, would you be able to sense that over 10 feet?
Nope, you'd have to go farther out. So go ahead and go farther out. And let me know when you get an actual measurement, and then you might have something to bring to the table. As of right now, you have no measurement to even bring to the table. We are the only one with the measurement.
But what I'm saying is that since it's an unfalsifiable measurement, because we don't have the precision instruments required to determine whether or not the curve was there,
Over
it's an
10 feet.
unfalsifiable measurement in that
Or at
distance.
10 feet.
You have an
So it's
unfalsifiable
worthless.
claim. No, you
So-
have an
so we're the same.
unfalsifiable claim.
I agree
I
with
thought
you.
you were done, bro. My bad.
No problem. Yeah, no,
Are
I'm
you
agreeing.
good, or
I'm
are you
agreeing
good?
with. I'm
'Cause I
agreeing
was
with you
gonna go.
there. So I'm equating us. We both have an unfalsifiable claim. You're claiming that
No,
over 10
no,
feet so it's flat. I'm saying that you can't claim that.
I don't have an
It's an invalid mean.
Yeah, damn, I thought you were done again. Go ahead, man.
I'm done.
I don't have an unfalsifiable measurement. I just have a measurement. You have an unfalsifiable claim that it's actually curving and we can't measure it. You don't have a measurement.
All right. And so what's your point?
My point is,
Let's
we
say if
are
I grant
sitting
that
here
to you,
with a
what does that mean?
measurement. My point is, we are sitting here with a measurement, and you don't have a measurement. You just have an unfalsifiable claim that, trust me, bro, it's curving.
But you're saying a thing. I'm saying, what's the point of the thing? And then you say the thing again.
The thing is, we have a measurement, and you don't. Hello.
You're repeating yourself.
That's the point. That's
Well,
the whole point. You
that-
don't have
that
a.
is the point, though.
But what's the
Where's your
meaning?
measurement of curvature? That's his question, essentially. Where's your curvature measurement?
Oh, so you have an imprecise measurement and I have no measurement.
What do you mean imprecise measurement?
I'm saying, so you have a measurement that's not to the precision that would be required in order to tell if it was curved or not, and then you're calling that flat.
Okay, what distance would you like to go? A mile? 2 miles? 10 miles? 100 feet?
Yes.
All right.
So here's what you need to do. Here's what you need to do.
How do I know that 100 feet's level?
You mean flat?
Flat, level, horizontal.
Yeah.
How do
Okay,
I know it's straight?
So you create a machine that can plane out a 100 foot perfect flat, like down to the I don't know what molecular scale, right? A perfectly machined surface.
Okay.
Micron measured, 100 feet long, and then you measure with perfect measurement the altitude at each end of the board.
All right, so this is back to the same conversation with Phantom. Let's say you go 700 feet. All right, what he said that's basically a turn of a traverse. So it's 700 feet. You're gonna have an error of 1/8 of an inch. Now, without correcting it, let's say we let that error compound over to the next segment.
Mm-hmm.
What would that be then? 2/8 of an inch, right?
Right, 1/4 inch.
That's 1,400 feet. Let's go all the way up to a mile. What would that be?
Another 1/2 inch.
About an inch almost. 7/8 of an inch or an inch.
All right.
Right. That's how much curvature we would see, or that's how much the error would be, right? A plus or minus, let's just say.
Okay.
Now, what does the globe claim after a mile? How much
8
curvature
inches.
should there be?
Mm-hmm.
And there's none. It's not enough. Even if you ignore the error correcting feature on like a theodolite or total station or whatever instrument you're using, if you ignore that, you're only going to have an inch deviation.
So you're
So
saying
that
that
doesn't
on
match
these
the
optical
globe.
measurements, it's an eighth of an inch off per
700
feet.
Yep. And then from line segment to line segment, if you add it all up to about a mile, right? 5,280 feet. That's about, a little bit over a 7/8 of an inch. So basically an inch deviation between those 2 points. Huh.
And
What
do
do
you
you know?
have?
It's
And do you
flat.
have?
Because
Do you?
guess what? The
Wait,
globe
wait,
claims
wait.
that it's supposed to be deviating 8 inches.
Wait a minute.
That's a huge difference, bro.
I literally don't know the answer to this question, so I'm asking just without
Yeah,
knowledge.
you're good.
Do these instruments measure altitude within an eighth of an inch?
Can I just say something real quick? You ended it with me on I have an imprecise measurement. I don't have an imprecise measurement. We have the most precise tools on Earth to measuring this, and it measures levels horizontal. The end. You have no measurement. We do. Thank you.
There's no curvature, bro. The only curvature comes from the idealized geoid that you have to reference in order to keep your sphere alive.
But wait a minute. In the question that we asked, and I asked a second ago, do those measure altitude within the precision of an eighth of an inch? Because you'd have to have that to do this experiment that you're saying.
I wasn't going off Beasticle's point. I was just going off my thing from us earlier. But
yeah, you were.
Go ahead, Beasticle.
Jeremy was just making more of a meta point about like, even if you threw out all of optics, okay, well, we still have measurements of Earth being flat. Like, there's no measurements of curvature. The only curvature that you can get is when you try to create a geoid, essentially.
Yeah, we went back to optics.
Yeah.
Long measurements.
Yeah.
So, but my thing is like, so what you'd have to do is machine out something that you can measure. You have to make a straight edge, a physical straight edge, and make it.
You need to make a
long.
straight edge so you can get a measurement. We got a measurement. You need to get a measurement now.
You're saying that you have a precise measurement, so precise to the limits of our ability. But
yes, the most precise measurements on Earth that humans can do, we have them. That's
the most
what
precise we can do. But
you
is
have
it precise?
nothing yet.
But if it's not precise enough for the task, then we can call it imprecise.
No, it's we have the most precise tool, the best measuring tools on Earth. Can't measure there being a curve. It's your turn. So that's a measurement we have, no curve. Level's not curving as far as the best tools on Earth can measure with the most precise instruments we have.
Does that prove anything?
So now, hold on. So now that we have a measurement, a tangible measurement, do you have a tangible measurement of it curving? Because we have one of it not curving. So you're saying, oh, you need to do something else. Do you have it?
I mean, look, I know I can't reference like, we had like a literal photograph of it, but you're gonna just say no, I don't believe it, so that's fine.
We tossed all the optical shit, I thought, and we were going with tangibility.
Right, and so you're saying that I have measurement instruments that are not up to the task of measuring the curve that would be there, and they don't show a curve.
No, I'm telling you, we have measurements of level being horizontal with the most precise instruments on Earth, and you have no measurement.
But the most precise instruments on Earth are not up to the task for detecting the curve if it was there.
But you're just saying it's there, though. We have measurements.
Yeah, trust me, bro, it's there.
We have measurements of it not being there, and you hold on, man. I was in the middle of talking.
That's my bad.
You didn't hear me. We have the measurement. We have the measurement of it not curving. You're saying, trust me, bro, it's there with no measurement of it actually curving.
Okay, you're putting words in my mouth. And then when I try to correct you, you say, hey, I was talking. So this is the thing. I'm not saying, trust me, bro, there's a curve. I'm saying you're making a point that you have measurements. And then I'm making the point, but you're measuring in a way that is not up to the task of finding a curve if it was there. So it's a meaningless measurement. So it's a meaning. If the curve was there, you wouldn't be able to measure it with the tools you have. And you're saying, but the tools I have show no curve.
Sure,
the tools I have, So what I'm hearing is the tools I have show no curve, but they wouldn't even find it if it was there.
Okay, and if it is there, we're not measuring it because these tools that we have are not measuring it. So if you want to say that it is there, cool. Show us a measurement of it being there. But up until now, we have measurements of it not being there. Do you have
I'm
any
not
measurements?
saying
Do you have any measurements of it being there?
what my point is that we're both in the same boat because I don't have a measurement at 10 feet of a curve and you don't have a measurement at 10 feet of flat.
No, that's all it measures is 10 feet flat. Level measures horizontal over 10 feet with the best tools, the most precise tools on earth. Now that's a measurement.
But
Do you have a
also which
measurement of it,
we've
of the
agreed
curve
that
being
those
there?
tools are not sufficient to find a curve at this scale.
Sure. I agree. If it was a globe and it was curving, then we wouldn't be able to measure it. However,
So then your
you're just
measurements are
saying
irrelevant to
it's
whether or
there.
not there's a
Hold
curve.
on, bro. Hold on. He said, however, he
That's
was
an
finishing his
implicit
point.
clause.
However,
JJ,
you're just saying it's
sorry.
You're just saying it's there, and you have no measurement to show that it's there. We have a measurement showing that there is no curve there. So I don't know. You have nothing.
You don't have a measurement showing there's no curve there. That's what you're claiming. You don't have that.
I do. It measures with the most precise measurement tools on earth. Level measures horizontal,
but it
tangibly.
But you don't have a measurement that shows no curve there.
We do because it measures horizontal there. You can't measure a difference from level and horizontal over this distance.
So you don't have a tool that measures no curve there.
Yes, we do. We have tools that measure level being horizontal over this distance.
No, but you don't have a tool that measures no curve there.
Yes, we do. We have a tool that measures level being horizontal. That's no curve.
Let's keep doing it forever. You don't
Horizontal
have a tool that
doesn't
measures
curve.
no curve.
Does horizontal curve?
Hold on, big tech.
Does horizontal curve?
What's the margin of error in your tool? Is it zero?
Does horizontal curve?
Is the margin of error in your tool zero?
But it measures flat within the margin. I want to ask you a question. Very simple. I put a picture in the chat. This picture in the chat is something I used to deal with. All right. When you talk about curve, no curve, yada yada yada.
I gotta find it. Which chat? Oh, you don't use the side chat here, huh? It's
live stream text.
Live stream chat. I got it.
Now, I want you to look at all that equipment. All right, that equipment gets dialed in by millwrights to the thousandths of an inch. All right, the tolerances of the spin of these things, and these things spin at thousands of RPMs. The tolerances of the spin are to the thousandths of an inch. They have to be perfectly leveled, and I mean perfectly leveled. All right.
What is this device, by the way?
These things. This is a turbine. All right, this is a turbine and generator. All right, at a power plant. I'm pretty sure that's what we're looking at right here. All right. So these devices are spinning at thousands of RPMs. They're massive. The whole assembly is probably around about 150 to 200 feet long, built into the concrete slab of the floor that it's on. They're awesome.
Okay.
If there was a curve over 200 feet, and we have to be precise down to the thousandth of an inch, wouldn't it become perceptible?
Well, creating a flat plane is possible. That's a created flat plane.
That flat plane is built according to elevation. Elevation, you assume, is curving. We assume it is not in construction. We assume flat and level. We never assume that level curves. We build level, and we build as if level is straight.
So again, this is a created flat plane.
According to level. According to level.
According to level.
Yes, flat and level are treated as the same in construction. We do not differentiate between them. All right. If we start at the 100 elevation, then when we shoot, we will stay at the 100 elevation.
So are you a
all
surveyor?
of our pluses and minuses will go back to the 100 elevation. All right. Even if your 100 elevation is curving, all right, which is what you're saying is happening, we go back to the 100 elevation. We don't go to the 101/8 elevation at 700 feet out because we assume a curve. No, we're going to stay at that 100 elevation, which means if I'm building a building and I've got a deck that's 700 feet long, you're saying that I have a curve in it, but yet all of my surveys tell me that it is a flat plane. And when I put equipment into it that needs to be dialed into the thousandths of an inch, it is going to work perfectly.
I hear you don't need to say another word. I get what you're saying totally. So are you a surveyor?
I am a carpenter who does surveys. I work with millwrights. I erect steel. I do civil. I do heavy civil. I do big boy shit.
A carpenter. So you're erecting the facilities?
I do the concrete work and some of the steel work. I do the embeds.
Got it. You do the concrete. But so you are not a surveyor, but you use surveying equipment for your pours?
So any carpenter is a surveyor, or at least he should be. Any journeyman carpenter should be a surveyor. Now, not all of them are.
You mean like licensed, or you mean just like you do surveying?
Listen, there's different types of surveyors. You have people who go out for the city planner surveyors who go out and they survey big swaths of land.
Mm-hmm.
That's planer. And then when the planer surveyors are done with their work, they'll call somebody like Shoebill in who does geodetics. Okay. And and geodetics will come in and they'll transform planer surveys. All right.
Mm-hmm.
I'm telling you that when it gets down to the nitty gritty of it and we build stuff, nobody ever accounts for curvature. Not on any construction site I've ever been on. It didn't matter if it was the Chickamauga Lock, which is a dam system that is on the Chickamauga Lakes down in Tennessee. Right? We didn't factor in any curvature. It didn't matter if it was the bridge in Kalamazoo. We didn't factor in any curvature. We treat everything as if flat and level are the same thing, or horizontal and level are the same thing. We always do.
So I have a background in industrial design and construction. And what I imagine took place in this facility is that machine right there, the machine which requires those tolerances of thousandths of an inch here and there, that machine is built within these balances and these alignments, and then it's installed on a slab. The slab, which was designed to accommodate the machine is perfectly aligned to be straight with flat, straight lines. And the machine itself, when it's installed, is on all sorts of pads, pillars, brackets, this and that. And these all have alignment capacities built into them. So the thing is shimmed and this and that to make the machine, the tunneling, the rotating, the cranks, whatever's in there. This is all aligned perfectly, and it's installed on a slab that is level to a degree that's tolerable to the machine. So, but it doesn't mean that what you have there is a perfectly flat, like molecularly machined, slab or deck that it's on. It means that the machine itself is aligned to be perfectly straight, and it's installed on the slab. So the surveying of the slab and the erection of the building around it has nothing to do with the alignment of the machine.
So, but do you realize though we're the only ones with a measurement here, and you don't have a measurement?
There we go. We're back. So yeah, neither of us have a measurement to the degree that it would either prove or rule out the curve.
No, we have a measurement of it not being there. We have a
I know
measurement
that.
of level
No, you don't
being
have a measure.
horizontal. It's not horizontal. Hold on, man. Horizontal is not curving.
How many times do I got to hear you say it over and over again, and then you say I'm interrupting you?
Because it's like you're not understanding. It's not.
No, I'm totally understanding. I'm just denying your frame completely. It's just false.
It's not. Nothing's false about what I'm saying.
Yes, it is, and I've said it over and over, and I'm tired of hearing it. To be honest,
we have a measurement of level.
You're the one who's wrong about
level
this.
being horizontal. Hold on. We have a measurement of level being horizontal.
Not
you're
perfect.
You're saying, well, the best tools on earth can't measure level not being horizontal over this short of a distance.
Yes,
even the globe admits that. So therefore,
neither of us have a sufficient measurement.
Okay, man. Nope. No. We have a measurement. You're just saying it's not a sufficient measurement because it's curving, even though you don't have a measurement of it curving. You don't have a measurement of it curving. We have a measurement of it not curving.
Sorry about that. I had to mute for a second. I had to be AFK. Whatever you said in the last 10 seconds, I wasn't able to hear that. My bad.
It's the same thing. You just keep trying to wordplay around.
Yeah, you're making a point that is meaningful to you, but it's not meaningful to me. So we need to let it aside. And it's not a cope. I just like literally, you're not acknowledging that you haven't established zero curve. You've established an imperceptible. You aren't able to establish a totally zeroed out perfect level, and therefore it's meaningless.
No, it's not meaningless. We have a measure. It's a measurement of level being horizontal. That's not horizontal. Doesn't curve. So we do have a measurement of level not curving.
But it's just not a good enough measurement.
You're
so it's
saying, come on, man, I'm almost done. You're saying it is. That's why.
You're almost done saying the thing you've already said 1,000 times.
That's probably why we keep doing this, because you never listen. And
you're almost done saying the same thing I've heard over and over.
Okay, but you can you acknowledge that you don't have a measurement?
Only if you'll acknowledge that your measurement isn't good enough. Then we'll both agree. But until then, we're at an impasse.
This guy was cooler before with Witsit. I don't know what's wrong with him.
Because this guy keeps repeating himself over and over and not acknowledging what I'm saying. And it's coming
I
across
acknowledge
as
what
like
you're saying. You're saying if there was a curve, you're saying if there, I acknowledged it multiple times. You're saying if there was a curve there, our tools aren't good enough to measure it. That's cool. And that's a neat story. But you don't have a measurement of it curving where we do have a measurement of it not curving.
And I'm denying what you just said, sir. You don't have a measurement of it not curving.
We do. We have a measurements of level being horizontal over that distance. Even the globe admits it's immeasurable. Level and horizontal measure the same at that distance.
Since it's, so you're saying not curving, right? So that means zero curve.
Horizontal doesn't curve.
But you don't have the ability to measure all the way down to zero.
Then nobody has a measurement of anything, ever. Then there are no, according to you, there are no measurements of anything ever anywhere on Earth.
Look, if I have a measuring tape that only has inches on it, and then you tell me I've measured this down to 1,000th of an inch, I say, no, you didn't. You don't have that measurement tool. And you say, but I have a measurement, and it's like, but it's not good enough. So that doesn't work. You can't use that here. I need it down to the 1,000th. And you're like, well, it's inches. And I'm like, no, I need a measurement. In order for this to matter to me, I need a measurement down to, I need 500 inches and an eighth. And you're like, well, I have 501. I'm like, well, that's not good enough. You're like, well, at least I have something. It's like, well, you have nothing if you don't have the exact thing. If you don't have the exact thing, you have nothing.
We have the best tools on Earth measuring level being horizontal over this distance. That is a measurement, whether you like it or not. That's an actual measurement. You are saying,
and so
if there's a curve there, you're saying, but if there's a curve there, you wouldn't be able to measure it. Okay, well, do you have a measurement of your curve?
What's that thing that you guys always say?
You don't. You don't. Do you have a measurement of your
curve? I'm sorry. I thought you were done talking.
Yeah, and you're not going to not answer my question again.
Oh, I'm sorry. You're
going. That's why we keep going in this loop, because you won't answer that question. You don't just admit you don't have a measurement of it.
Here's my answer. I learned this one from Witsit. Falsification is independent from replacement. And you're asking me to replace it.
It's not relevant.
Falsification is independent. I falsified you, and then you're asking me to replace it with it. Well, where's your measurement?
You didn't falsify.
I falsified
yours. Me. You didn't falsify mine.
I did by saying that it's not sufficient.
This whole thing just hinges on shifting the burden of proof fallacy. That's what it is, shifting the.
And I'm saying neither of us have proof, and you're saying, well, where's yours? And I'm saying neither of us have it. Well, you don't have any. Neither of us have it. You're saying, yes, I do. And I say, no, you don't.
I do have proof. We have a measurement of it not curving. Horizontal horizontal doesn't curve.
But if it's an insufficient measurement, it's not proof of anything.
It's not. It's the best tools on Earth.
But if the best tools on Earth are not for the job, then they're worthless.
But it's a measurement of using the best tools on Earth, and you don't have anything. You're just saying it's there, and if it is there, you wouldn't be able to measure it.
Well, okay, fine. I'm just going to give you what you want. I agree with you, and you're just not going to give me what I want. So I'm going to be the generous one, and you're going to just do whatever you want. I agree with you that you have I agree with you that you have a measurement.
Okay, thank you. And I agree that if it was curving, that's not long enough to measure it.
I don't know what we accomplished with all of this, but all right.
You did have
what we accomplished. I'll tell you what we accomplished right now is we, the flat earthers, are sitting here with a measurement, and you don't have one.
And I don't know what that accomplishes.
It accomplishes, we're the only ones with a measurement.
And I don't know what that accomplishes.
You have no measurements.
And I don't know what does that have to do with anything?
You said you had
It
80
means basically that your claim, which is not
Or an eight-
substantiated, is dismissed.
No, false. That's a wrong
You
conclusion.
said
Non
you'd
sequitur.
measured it earlier. You said you'd measured it earlier.
At 10 feet?
Over multiple transits. No.
No, we're talking
Over
about
a
10
mile
feet. We're talking
and
about 10
over
feet. That's a
700
whole
feet.
different conversation.
Well, no, it's about a measurement. Doesn't matter. 10
No,
feet.
no. He asked me to put
You
that.
said
We
you
put
could
that
discern
aside.
it over 700 feet.
I'm talking to this gentleman about the 10-foot measurement specifically. He's saying he has a 10-foot measurement. And I'm saying it's not a good enough measurement to make any claims. And he's saying, but at least it's a measurement.
Yeah, but you agreed you hadn't got a measurement. But where's
I'm
your
trying to
measurement?
get a concession from your side.
I
If you're
did.
being
I
intellectually
conceded.
honest,
I conceded
if
over
you're being
time.
intellectually
listening.
honest, you have to admit that neither of us have a good measurement of a curve or flat at 10 feet.
No, hold on. We do have a good measurement over 10 feet. It's with the most precise tools on earth. That is
Is
a
it
good
good?
measurement.
Is it good enough?
If it was curving, which you don't have a measurement of, but if that was happening, it's not long. It's 10 feet is not long enough. I agree to that. However,
that's all I'm saying.
both of us are sitting here. I have a measurement of my thing, level being horizontal,
And I'm
you
saying
don't have a measurement of your thing, level curving.
You know that I've heard you say that. And the fact that you're saying it over and over, it's just like, it just comes across rude. So, I kind of I don't think I deserve to be mistreated. And it's coming across that way.
Well,
I have a measurement, you don't have a measurement.
you.
I have a measurement, you don't have a measurement. I have a measurement, you don't have a measurement. I have a measurement, you have a measurement. But I have a measurement, you don't have a measurement. It's like, bro, what are we doing?
I know. Well, that took a long time. We've already both agreed. You agreed that I have a measurement, and and I agreed that if it was curving, which you don't have a measurement of, that's not long enough. We both agreed.
Right. But then we also, I guess we agreed that your measurement is meaningless in this context because it's not precise enough. It's the best we have, but it's not good enough. So, and not good enough is not good.
That's you making another positive claim that you're not substantiated.
It's like I took a shot that was the best shot we could possibly take. It's like, but it's not good enough to hit the target, but it's the best shot we can take. At least I took a shot.
The target that you're
just saying it's not good enough,
which you don't have evidence. You keep on making this implicit positive claim, and you're failing to substantiate it. The burden of proof is on you. You haven't substantiated jack, so it's concede. It's like you have to concede, bro. Otherwise, you're just intellectually dishonest.
No, he's making the claim that he's established zero curve, and I'm saying you don't measure down to zero, so you can't make that claim. There is a margin of error then. Thank you.
There's a margin of error.
And the margin of error is too big to rule out a curve that would be there with that radius value. So it's meaningless.
That a curve that might be there that we don't know is there, so it's just speculation,
right.
Unless you're
it
making the positive claim.
So
for which the burden of proof would be upon you again.
So within
you keep on shucking away from the burden of proof.
So establishing flat means ruling out curve, and you don't have the measurement of capacity for ruling out curve at that distance. So you can't say that you've established it as flat.
We do
flat to a degree that's not precise enough.
Tools. That's you again making the positive claim that it has to be more precise because of this supposed curve. Where is the proof of?
We're arguing about whether or not there's a radius value of this size that's perceptible at 10 feet, and you're saying we've measured the burden of proof.
Classic shifting the burden.
I'm sorry?
He said it's shifting the burden of proof. We have the measurement.
I'm not asking you to prove anything. He's saying that, no, what he's actually doing is saying he's laying claim to a debunk of the curve that he can't.
No, I'm telling you, that's not, dude. I'm telling you, we have a measurement. You don't even have a measurement. I don't know why you're even at the table because you don't have a measurement to bring. When it comes to this,
but it's irrelevant. It's meaningless. It's meaningless. You're making a meaningless point.
It's not meaning. It's only meaningless because you're saying there's a curve there for which you don't have a measurement of. That's the only reason why you're saying it's meaningless.
But you're saying that there's a perfectly flat plane there that you don't have a measurement of.
No, I didn't say we have a perfect. I never said perfectly flat plane. I never said those words.
Well, if it's anything other than perfectly flat, then it's curved.
That's not true, dude. You don't have a
Not
measurement.
perfectly flat is a not per, if a line is not perfectly flat, then it's non-flat.
Why are you
What about if it rises in elevation?
It's nonsense.
If either the line is perfectly flat or it is a curve. Those are the two options.
I mean, he's right about, but like you're only speculating that there's a curve. You're making this implicit positive claim.
And that's what I'm saying is that based on the level of your perceptive measuring, you're laying claim to a perfectly flat plane that you can't. You're claiming to have evidence of something that you don't. Right. So
again,
you haven't ruled out. You haven't ruled out a curve.
Planar, and you're just sucking and jiving away from burden.
We haven't ruled out the baseless claim you keep making that if there's a curve there. Yes.
Right.
Right.
So you have
The
a measurement
is the same.
that is inapplicable to this conversation.
Is the same in both cases, isn't it?
Right. So I'm saying that we're on equal footing.
Is horizontal on both sides of this conversation.
Yeah. So what I'm saying, I'm not shifting burden of proof. I'm saying that you're making the claim that you are basically have something more than me, and I'm saying we're actually equal. We both have an indeterminate measurement.
No, we're not equal. I have a real measurement of level being horizontal. That is a
but it's
real
indeterminate.
It's only indeterminate because you're saying maybe there's a curve there. If you have a measurement of your curve, let's see it. Otherwise, we're the only one with a measurement of level being horizontal.
You have an indeterminate measurement of level being horizontal at 10 feet.
Do you have any measurement?
Only.
Is an indeterminate measurement better than no measurement?
Do you have any measurement of the level? You're only saying it's indeterminate because you're claiming there's a curve there, which you have no measurement of.
I'm sorry, say that again.
You're only saying it's indeterminate because you're claiming that there's a measurement, that there is a curve there, which you have no measurement of.
Right, because my understanding of the curve doesn't come from a 10-foot measurement, sir.
You don't have any. You have no measurement. We threw all the optical shit away 5 minutes ago.
Right, because we couldn't agree on what happens with light over distance.
Exactly. So now we're down to tangibility.
The curve comes from the stories he's been told.
No,
it's found out of this measurement you're talking about.
Pictures from
by transits of a horizontal reference and elevation changes, measurement and elevation changes. Not optical, only by looking through the audio level.
So you know what? Actually, I'll give you...
and then you transit from one horizontal to the other, maintaining the integrity of the horizontal reference from beginning to end and back again. And over that distance, you measure elevation changes.
I'll give back to you. Actually, I said no to the thing I shouldn't have. I agree. I think we're in the same camp there. I have a story.
You say.
No, I'm talking to the other fellow. I'm sorry. The men who spoke before you. I didn't catch the name, but it is a story. You're right. There was a story that I've been told that I have adopted that makes sense to me. I agree with you that that's why I believe in the curve. I totally agree with you that that's right. And I think that you're doing the same thing. You've actually discovered another story that makes more sense to you, and you've adopted that story, which is that the Earth actually is flat.
Sure,
so we have two different stories.
Okay, so you believe a story that you're told. So you're taking it on faith that there's a curve.
In the same right, and that's what you're doing too.
All right, but mine, again, there's a measurements for it, right? Whereas for yours, there isn't measurements. So who's got the?
But what I'm saying is since you acknowledge that there's a margin of error that is too much to rule out curve or flat, then I'm saying that what you have is a potentially erroneous measurement. And you can't build a dependable narrative on an erroneous measurement.
Maybe, but we judge by what's apparent. We use this as flat in construction, all applications in life, right? Even on the globe, they use things as locally flat and stationary in terms of like aviation and what have you, weapon system, all that stuff. So I got the upper hand.
If you say so, but let's go with this. I like this line of reasoning that they're both stories. Let's compare the stories.
No more questions.
I'm sorry, what?
No more questions.
I don't. Did you say no more questions or one more question? You're cutting it out a little bit.
Sure, one more question.
Okay, go ahead.
No, I thought you had.
I don't know what's wrong with your mic. I'm just hearing like little blurbs of sound.
Yeah, percent. You're not keeping your
Oh,
mic
my
open long
bad.
enough or something. Like, I don't know what's going on.
You can change
Yeah,
the
maybe
drop
change
off.
So you
Yeah.
said that I have a story that I've adopted that I was told and I believe it, and you have a different story that you're saying is based on a measurement. So we have different stories. Now let's compare the rest of the story. In my story, I have an idea where the sun goes at night. It looks like it goes in the water, but I think it's going behind an object so that it's obstructing the light. Where does the sun go on your story at night? Where is it?
It goes too far, it converges into the right.
I really want to talk to you, and I'm not being a jerk, but I just can't hear you. You're cutting
Yeah,
in and out.
percent. You're not leaving your mic
Percent,
open
it
for
goes
long
too
enough every
far.
time you talk.
All right, it goes too far and it converges into the horizon.
Okay, too far is not a location. And I'm asking, where does it go?
Away from us.
That's a direction, but where is it? Locate it for me.
In the sky.
Are you being intentionally vague?
No, I'm just being as clear as I can be. I mean, can't make claims to like, you know, or knowledge that I don't have. So I'm not going to tell you the exact coordinates that it's in. Like, we have to get more specific if that's the case. But I can tell you that it continues moving away from me to the point where I can't see it anymore.
So in your story, you're unable to locate the sun?
No, I'm saying the sun moves away when it sets, and then I can't see it anymore.
But in
Someone
my
that's
story,
close to
I
it
can
can
tell
see it.
you right where the sun is, and I like that feeling. And in your story, I'm asking you to tell me where the sun is, and you're failing to be able to do it. So your story seems inadequate.
How
to
can you tell
locate
me
the sun.
right where it is?
Sorry?
How can you tell me where it is?
Well, in my story, it's 93 million miles away, and it's staying in the same place relative to me, and I'm rotating. So it's staying right there. In your story, it's moving somewhere else, and I'm saying where?
Yeah, it's constantly moving, like away from us, constantly going around in its circuit. And I challenge your like what your claim
going
to if
around
there's
in
any
a-
evidence.
it's
for it.
going around
I
in
think we
its
agree.
circuit?
I think we agree with this in terms of us. The sun visibly, you know, moves farther away from us as it sets. Right when it
does the
rises,
sun-
it comes closer to us, and when it sets, it moves farther away from us. We agree on this. But you're going the next step, making a positive claim that it's 93 million miles away with zero evidence for that.
But I'll just go ahead and say for the sake of this conversation, that's just my story that I'm telling myself that I heard from some guy. But in your story, does the sun move around in the sky in a circle like the hand of a clock?
I wouldn't say it's. I can't say it's a perfect circle, but I do believe it moves in a revolution, in a orbit or in a circuit. You could use any one of those.
So it's an imperfect circle. It's some sort of like spiral pattern, spirals in toward the what we call the North Pole, and then out toward the South.
I didn't say it was
something
an
like that.
imperfect circle. I said I can't claim that's a perfect circle. It could be a perfect circle, but I just can't claim it because I don't have like absolute knowledge of its circuit.
So in your story, you don't know the circuit of the sun.
No, because I don't have eyes on it 24/7. I can't follow it. Like it's faster than me.
Even
Plus, I
working
don't
together
have,
with all
like,
your
a
buddies
perfect
around the world, you
map.
can't figure out the circuit with your story?
Plus, I don't have a perfect map of the world, so I don't have buddies all over the world that have the technology necessary to be able to see the sun from like a top-down view to know exactly the shape of its orbit. I don't have that.
All right, so you have a measurement, and I
Have
don't.
you been above the sun?
But I have a story that works, and you don't.
Working is pushing it. But have you been above the sun to see its circuit?
It doesn't have a circuit in my story.
Oh yeah, then with zero evidence. But mine is actually like it's something we agree on. See, for me, it's basically what I'm claiming is that which we agree on. It's the common denominator. you wouldn't disagree that the sun has a circuit and that it moves closer to us when it rises and moves farther away from us when it sets visibly, right? You would say in actuality it's stationary, whatever, but that's positive claiming. You have no evidence for it. So again, it's like, what do we take? The thing that we like, the null hypothesis, or the alternative hypothesis that has no evidence?
So what it appears to do is you go up at dawn and then overhead at noon and then down in the evening. But in my story, I'm on a rotating sphere that causes that appearance. In your story, it's going on some circuit that's not perfectly definable. We don't know.
Again, in my story, it's doing what we agree it appears to do. So we agree, as far as I'm concerned. I'm not making any additional claims, but you're making the claim of it's stationary, huge, and 93 million miles away. Evidence.
What it appear? No, wait. What it appears to do is go down in the water over the Pacific Ocean in the evening.
No, sometimes it appears to just like, get smaller as it goes farther.
No, it never does that.
Yo, can some bros post like some gifs? Apparently, this guy's never seen gifs like that.
Oh, you're gonna show me some like
I'll grant you. I'll steel man you and say yes. If you use
anomaly.
Hold up, I'll steel man you and I'll say if you use the solar filter, then it doesn't. This like effect is not like as it is when without a solar filter, obviously. But
I'm saying like if I stand on the beach any night of the year, all year long, it appears to go in the water.
Yeah, it's fine. Not all the time. Not any night. There's some nights that are cloudy and stuff like that, and it just like looks like it gets smaller and smaller as it is setting. And I'm surprised that you haven't seen any gifts because you sound like you're kind of well versed in this topic. I'm surprised you haven't seen
gifts. Gifts are gifts. I mean, I could show you gifs of
videos,
astronauts.
actual videos, like
Yeah, I could show you videos of the Earth curve. So my point is, if I look at the sun, which I've done, I live in California, so I love going to the beach, surfer, the whole thing, seeing the sun go into the water hundreds of times, goes right into the water. So if we're saying that the sun does what it appears to do, then we have to say the sun goes in the water at night.
No, we know it doesn't do that because we have the the what's it called? The experiences of other people, right? And they observe it to stay in the sky. It's always staying in the sky. So I would agree with you. It's an optical illusion. It's an optical illusion that it looks like it's going into the water.
So we both agree that what we see in the sky is an illusion of some type.
That it goes into the water when you're viewing it with like a solar filter. Yes, I would say that's an optical illusion. I would say it's an optical illusion caused by atmospheric magnification and perspective.
So whatever the cause, what it appears to do is something other than what it's actually doing.
No, but we agree that it appears to in the sky when you just increase your scale, right? When you rely on other people's experiences. So we have eyes on the sun at all times, and we can assert with confidence that it stays in the sky. And this is our experience and our observation. We're just not limiting it to one person.
So okay, again, well then we're back to me asking you where does the sun go, and you said I don't know because I don't have eyes on it all the time. But now you're saying because
I said
other
it stays
people
in the
have
sky and gets farther away from me, right? It gets closer to someone else, but farther away from me.
Right. So if we're going to appeal to other people, which are all over the planet, we can track where the sun is.
You mean all over Earth? Yeah, we can track where the sun is. Yeah, but we never track it to be 93 million miles away. That's a positive claim that you still haven't stepped back.
Yeah, that's a story I tell myself because I got brainwashed as a child by Neil deGrasse Tyson.
Me too, man. I Bill just Nye.
I mean, Bill Nye. Bill Nye, the lying guy, told me it was really far away, and I bought it, and I still believe it, and I'm just like in the paradigm.
How much did it cost?
But the thing is, for me, that story is able to answer some questions that when I ask these questions of you, it starts to get shaky. So while you might say that I have a measurement and you don't, it's like I have a story that makes sense and yours you don't.
What question have I not answered?
Well, I guess the next logical one is, what's your explanation for what Witsit saw in Antarctica? How does your story explain that?
All right. So to be fair, I've answered the questions before. Now you're like trying to introduce one that I can't answer.
There we go.
For the 24-hour sun, in terms of how it works on what? There's a 24-hour sun in Antarctica.
How come it didn't go far away from Witsit? Why in Antarctica does it not go away? Like it does everywhere else?
I still think it moves farther and closer, and that's why it was like, at its zenith, during noon or whatever, and then, like it was lower in the horizon at sunrise and sunset, but so it's still like, it matches what I'm saying, but just doesn't get far enough away for us to not see it in the south.
But why not?
Can I ask a quick question? Do you think the sun is circling parallel to this flat Earth? To stay the same elevation?
I think so, except maybe there's slight differences with the maybe with analemma there might be slight differences, or maybe the analemma is just like differences in its directionality. I'm not sure exactly. But
so that means, so that would mean that from sunrise to noon, the movement of the sun has to slow down, and then from noon to sunset, it has to accelerate to maintain 15 degrees per hour. How do you explain that?
Why is that?
Simple geometry.
I don't think what you're saying is accurate. You have to
show me what
you.
I appreciate that this question is probably a good one, but do you mind if we stay with the Antarctica thing before we move on to
I'll mute. Sorry.
All good. Thank you.
Yeah, post your proof in the chat.
So back to the story. Since my story is able to answer this question and yours isn't, then I get to basically say, okay, maybe you have a measurement and I don't, but I have a story that works and you don't.
No, I mean, I have a story too that can answer it, but I can't claim it's absolute fact. It's speculation, just like your entire story is. This one part of mine is speculation, and I speculate that the observation of the sun sometimes, like especially towards the south, has like this maybe it enters into like this dimensional rift or something where it's like it's like the Pac-Man type Earth. That's my speculation, but Allahu Adam, God.
A dimensional rift, Pac-Man Earth? I don't mean to make fun
of
it.
You
Is that what you just
never
said?
heard of Pac-Man?
No, this is new to me.
Well, that's my speculation. But I'm not going to say it's the
I don't even understand your speculation. It sounds like you're appealing to something like very abnormal. And the foundation of your claim originally was that there's something it's happening like what it looks like, which is that it just goes far away out of view because of angular resolution. And then I said, what about this? And you said Pac-Man Earth.
Yeah, absolutely. Any claims that I make are what we observe, right? But for like this, what the sun's path in Antarctica, for that it's speculation. I'm not making any claims. It's just my speculation is that there's like this Pac-Man Earth effect.
So I
make one speculation so far, and you've made tons. And honestly,
what
I don't know what's more unbelievable: Pac-Man Earth in the south, or 93 million miles away sun. So
I think Pac-Man Earth is more unbelievable.
Maybe just because you're used to the 93 million. If you were raised thinking it was Pac-Man Earth, I don't think you would find it that unbelievable compared to 93 million miles. But it's a genetic fallacy. So,
well, the idea of things being far away is very familiar to me. The idea of interdimensional rifts or something, whatever that was, is very foreign.
Really? What about wormholes?
Never seen a wormhole.
But doesn't your story say that they exist?
I don't know. No.
Sounds like you don't know your story.
Where's the wormhole?
Don't they say that with black holes, singularities, you know, anything beyond the event horizon can be considered, you know, can be potentially like a dimensional rift into another time and place, because the time and place is dilating and bending. They're theorized, but they've never been.
We're so that's us imagining what happens in a place that we can't see. But I'm asking you to explain something that we do see.
About your. Well, how are you going to see a black hole? That's a different topic altogether.
Yeah, so I don't think that you know, some astrophysicist's theory about what happens in the far off universe where we can't see is I think it's a weird equivalency to say, like, well, why does the sun do something weird?
When does it become part of your story? I said, when does it become part of your story? When enough astrophysicists say it, or like if just one person says it, it's not part of your story. It's just like, is it like argumentum ad populum? If enough of them say it, we'll just take them.
I have to consider this. Let's see. Well, what if I just give you that? Let's go internal critique on this. So they have a reason to say that, though, that comes from, you know, some math, some laws of physics that they're analyzing, and the matter and material, and they're extrapolating based on principles that we understand and have tested.
I challenge you on that, because reason is evidence, right? And it's like, you know, so far we haven't had any evidence from you. It's just a story. So what's the reason for them to say that,
no,
that wormholes
it's mostly math.
Come on,
these
man.
are mathematical.
Is input equals output. If it's garbage input, it's garbage output. If there's no evidence for the input, there's gonna be no evidence for the output. It doesn't matter.
So the math could be bad, and we could have a bad theory for some bad math that we've done. But what we're talking about is what we're seeing here with our eyes. We're not talking. So that's a different category. Math is a different category than I'm seeing something happen and I can't explain it.
Well, math is basically part of your story. So it's like, whose math do you believe? How many, like, you know, mathematicians have to agree on this person's, you know, theoretical math, this model that they've made up for you to believe it.
But my story existed long before the idea of a black hole or a singularity or a wormhole or anything existed. My story was already there. So my story doesn't hinge on
your story is constantly changing, right?
Well, it's expanding.
Yeah.
But it's not fundamentally changing, it's just expanding.
Yeah, but it's changing based off of ideas that are not substantiated. Just, you know, people's, you know, enough astrophysicists agreeing on a certain concept, like dark matter.
There's embellishments that are being added on, you know, additional, you know, it's being enhanced. In fact, it's not fundamentally
Why should I believe
changing.
any of it without evidence?
Well, literally, just like the inductive logic leads to the one that makes most sense. Whatever makes the most sense.
I think mine makes perfect sense, but, you know,
the Pac-Man wormhole sun in the south.
That's only a speculation. I wouldn't make any claims with that, but everything else is substantiated, you know, by actual empiricism and, you know, observation of people on Earth. So,
okay, let's ask it. But you agree, though, right, that the 24-hour sun in Antarctica matches my story better than it matches your story, right?
No, I think it perfectly matches with like a Pac-Man theory. Absolutely.
Bro.
I think it's neater with yours. Absolutely. Like I think that having two poles.
It's funny that you mentioned changing stories, because I've never even heard anybody say Pac-Man wormhole sun until you discovered the 24-hour sun in Antarctica, and now you're changing the story. You're doing what you're accusing us of having done.
You don't know me, I guess, so you can't make that claim.
Well, so you're an anomaly in the flat Earth circle then, because I've talked to a lot of flat Earthers. Nobody ever brought up a wormhole Pac-Man thing with me.
Probably. I'm like, you know, it's not a rare thing that I get muted for me pushing back on, you know, by other flat earthers and other flat Earth servers for me pushing back on their dogmatic beliefs.
But how long have you had this Pac-Man wormhole idea?
I'll answer your question by agreeing with you. In terms of the globe model, there's some things that, like, there's stronger arguments, right? One of them is in terms of like the two celestial poles, they fit together neater on a globe. So it's a strong proof for the globe, right? And before Antarctica and before the 24-hour sun and stuff like that, this like I realized this, I knew this, and for me the answer was that the way that the equatorial stars are shared all around the world, you know, because we have eyes on them, we have people living like near the equator all around the world. And the reason, the way that they're shared between two celestial poles on a planar surface is by the outer stars, you know, basically being Pac-Man, so that the observation is shared. That's, you know, that's the logical kind of inference I made. But speculation, I'm not claiming it's the truth, just that's my speculation of how.
All right. Well, from my view, so I think that we're back to being equal again. Even if I give the other fellow who was saying that there's meaning behind the idea that we have a measurement relative, regardless of how precise it is, at least we have a measurement. We have this thing we call level, and you have nothing. If he says that to me, from my view, it's the same. I have a story that makes sense. Where's yours? And I don't accept this Pac-Man wormhole idea. It seems too alien, and I can't accept it.
That's fine. I mean, you know, it's new to you. You have an inherent like bias with what you've been told and stuff. So it took a little bit for me to you know to get used to as well.
And can I examine your story a little bit more? If I were, I would ask, in your story, why does the jet stream do what it does?
There are a bunch of jet streams. Which one are you talking about? Like, what do you mean specifically?
Pick anyone you like.
I don't have a preferred jet stream.
All right, let's say the one that goes over North America, the one that goes causes the planes to fly a little faster west to east than east to west. In my story, it's related to heat exchange and the Coriolis effect, where high pressure systems are moving to low pressure systems, which means the high pressure is going to the north. And as it goes to the north, it's also deviating a little because of the rotation of the Earth. Because of that deviation over the curve and the shortening of the distance around the circle as it goes closer, higher up in latitude, we end up with this basically an air convection system, which can reach hundreds of miles an hour, in fact, like way up high. So in my story, there's an explanation that the rotation and the shape of the Earth add up to this pressure system going in one direction. And it, you know, it meanders here or there depending on what part of the landmass that it's on, because there's different temperatures arising from the land and the sea. But in general, it's always still going in one direction, east to west or west to east. And that's explained by the shape and the movement of the Earth in my story. In your story, what causes that?
Sorry, I cut out for a bit, but I think I got like the majority of what you're saying. You're basically saying that the Coriolis effect causes the jet streams, the western jet stream over North America. Is that what you said?
Yeah.
Okay, and you're asking what my, you know, what? How do I explain it? To be fair, I haven't given it much thought. I would say it's variations in you know, just the temperature and pressure. But are you claiming that there's like that it's different in my conception?
I just don't even know what would the causality of the direction be.
If cold air moves to hot air and the sun rises in the east, then the cold air would be in the west, right?
Right.
Good point.
So then the same explanation you use could be used that the sun's movement causes the Gulf Stream or the jet stream, sorry.
But that's actually the opposite direction that the jet stream goes, isn't it?
No, it's the same direct. It's
No,
the cold air
east to
moves
west.
to hot. I just explained it to you.
Yeah, Big Tech, you said westerly, right? So it makes sense. Thank you. That actually, that's very simple and very, very poignant. So if the sun's rising in the east, it's heating up the stuff in the east, and then it's moving east to west. That makes sense. Hot to cold.
But normally, though, high pressure areas are warm, and the high pressure moves towards the low pressure areas.
Yeah, but so the warm pressure is high, and it's moving to the cold region. And you're saying that since the sun rises in the east, why would the warm air in the west move east if the sun's rising in the east? It would actually flow the other direction.
Because it doesn't heat it up instantly. The sun has to be like in the air, and like it has to be lighting up the place and heating up the place for a while before the ambient temperature starts to like the hottest time of the day is between like 2 and 4 p.m. right when the sun's in the western sky. So
still high pressure areas during nighttime is warmer than low pressure areas normally in the northern hemisphere.
Say that again. Can you say that
normally
again?
At least in the summertime, if you have a high pressure area, it's warmer even during the night than it is when you have a low pressure area, at least up in the north where I live.
Right.
Yeah, because the high pressures.
So my point is that if it was the sun, then the high pressure would be where the sun is, and it would be moving toward where the sun isn't, which would be moving west, because the sun is always not west. It's always
depends on your elevation.
From east to west.
That depends. That all depends on your elevation.
What I said. Like when you go to the beach, you don't want to go in the morning. The water's still cold. It hasn't absorbed the thermal mass of the water hasn't absorbed enough of the heat of the sun for it to be warm, right? You have to go later in the day. So it makes sense that
because the warm air is
wind,
in the
which,
east
by the way,
behind
can absorb.
you.
Hold up. So it makes sense that the wind, which like the atmosphere, will absorb the heat even like slower than the water of the ocean will. So it'll take even longer. So it makes sense that when the sun is crossed its zenith, when it's in the western sky, that's when it's reached that threshold of heating up the air, and you're expecting these westerly, like these winds in the west to go east, which is what you're saying. High to lows, west to it goes westerly, and then when it's in the east again, it's like cool down and so on and so forth. So I don't understand why that doesn't work.
Yeah, no, it definitely doesn't, though, because if it was the sun causing it by its movement, then the air would be moving away from the sun, which would that means
different elevation. No, dude, at different elevations, you're gonna have one elevation doing that, the other elevation doing another. It's like a big circle. You understand that?
No, I don't get that.
No. Go ahead and look at the wind patterns on the Earth versus the jet streams.
What does it have to do with the elevation?
Because the jet stream that you're claiming is at a specific elevation. It's not like at sea level. Like if you were to fly a plane, 3,000 feet above the ground, you're going to have the same effect. Do you think so?
But if it was the due to the sun, okay, it's at sunrise, as you claim, or let's say at noon, then from my reference point, the jet streams move away from the sun. So that would mean when it's noon here, the jet stream will move both east and west.
Why would you make that claim? I'm talking about at elevation.
Because if you are saying it's due to the sun,
specific elevation.
Hang on. If it's due to the sun heating up the atmosphere, and as the sun moves during the day, it rises in east, sets in west. And if you say that the due to the sun heating up the air is moving from sunrise is moving west, well then at sunset it should move east.
Why should it do that?
Yeah, why? What are you talking about?
Based on the claim that it was due to the sun, as it rises in the east.
Wrong, though.
I guess my point is, what we have
where the
is
sun is, it's still going to be warmer. So even if it's
What we have
sunset,
is-
where the sun came from, which is the east, it's still going to be warmer. So it doesn't make sense for it to now suddenly switch directions.
In the morning, yes, but in the afternoon when the sun sets, it's warmer in the west than in the east.
You're not talking about 35,000
maybe just
feet.
marginally, but I don't think it'll be enough to switch directions. Like, you know, the momentum that the wind has now, it's going to suddenly switch directions because the sun's leaving. I don't think that's how it works.
Well, if you claim that it westerly movement of the occurrence though is because the sun is coming up in the east, well, you should have the same effect as it sets in the west.
That's my speculation. He's asking me to speculate more, right? And
I'm not just speculating. I'm
basing
my argument on the claim that is due to the position of the sun.
Again, I'm speculating that the currents are caused by the movement of the sun, and that was, thank you again, Tora, for that. I'm not saying it is that because I don't have, knowledge of all of the movement of the wind and stuff.